a žije. Akurát, že tie mikrofóny takto fungujú.
Mikrofón treba mať takto blízko, aby ma bolo počuť tu v celej miestnosti. OK. A nemusím mať úplne tak, že budem do neho takto, že stačí takto, ale nemôžem ho mať tu.
Nemôžeš ho mať tu a nemôžeš ho mať takto. Lebo ja to, vieš čo, najjednoduchšie to hovorím ľuďom, že predstav si to jak baterku, že svieti. Tam, kam svieti, tam počuje.
Aha, takže takto.
Takto nepočuje.
Tak on je ako smerový? Aha, OK. Takto, a takto len je smerový. OK. Dobre.
Akože úplne celá špecifikácia je, že dynamický mikrofón, dynamická kapsula s kardioidnou charakteristikou. To je toto. Okay. A tá charakteristika vyzerá tak, že to sú také ladvinky, takto lúč dopredu a toto ladvinka. Čiže tuto od niekiaľ počuje, ale tuto počuje úplne perfektne. Okay. A tým, že je dynamický, lebo sú ešte kondenzátorové kapsule, tie sú oveľa citlivejšie, ale to tu nechceš, lebo by to pískalo. A dynamika je veľmi citlivá na to, jak blízko je. Čiže ty, keď budeš toto robiť, tak to znie úplne jak hnoj.
OK, takže musím to mať takto a nebehať s tým hore-dole, lebo proste potom je to na hovno.
Okay. Keď budeš mať takto mikrofón a konštantne, tak zvukár dorieši, ale treba tento grif si nájsť, že nech robím, čo robím, alebo vysvetľujem, tak mám ten mikrofón rovnako.
A boli s tým aj problémy, že tu ľudia akože chodili kade-tade?
Bežne. A to je vždy. Ale vieš, úplne najhoršie, keď robíme buď polyglot, alebo nejaké takéto a Taliani prídu. Lebo Taliani sú, že...
Rozhadzuje strašne rukami a tak.
Jak mám povedať polovicu vety, keď mi dáš mikrofón do ruky? Ty zoberieš moje ruku, to je konec. Dobre. A to je teda najhoršie, čo sa môže diať, že robíš toto, lebo ja keď napríklad, že máš takto mikrofón, ja dvihnem gain a nejako to dobieham, ale v momente, ak ty zabučíš, tak to zaväzbí. To akože to není pomoc. To nejde dokompenzovať vtedy. Čiže už je to aj také, že keď niekto toto rieši, v sále ho síce počujem málo, ale ja si to vytiahnem do záznamu, aby som niečo mal, ale keď mi začne niekto toto robiť, to je konec.
A to ani nejaká automatika nevie akože...
To nevyriešiš. To je tak strašný rozdiel. To sa bavíme o desiatkách decibelov rozdiel. To je strašne veľa. Akože v postprode my tam robíme dynamiku na tom, aby to zrovnalo, ale aj tak tam počuješ. My to počujeme. Slajdo ti pustí, potom pustíš sem na konci. Ale treba ho moderovať.
No ja viem, ja tu mám otvorené, takže akože vymazať si veci a potom keď odpovie, tak ako vyhodí to a tak. Dobre, len ho pustíš, to som chcel vedieť, že to...
Jak dojdu na ich slide Q&A, alebo respektíve skončia, tak ja hore hodím.
Myslím, že posledných 5 minút pred koncom sa dáva signál, môže končiť, alebo ja si vlastne skočím po také cedule, že po kartičky si idem, no to si ešte idem zohnať. Dobre, ešte máme 15 minút, 20.
Jup.
Do you want to take a picture?
Yes, please.
Is the audience?
Yeah. Oh my God.
Okay. Okay, hello to our second day of our conference. I hope that you had a pleasure day yesterday, and now we are continuing with the second day. And now we have the OpenTelemetry, the plays over by Andrea Villela and Josh Lee.
Thank
Hello.
you so much. Hello. And thanks for coming early on the second day for our talk. We really appreciate it. So welcome to OpenTelemetry. Playtime is over. My name is Adriana Villela. I am originally from Rio de Janeiro, Brazil, but I currently live in Canada. I'm a CNCF ambassador, OTel community manager, maintainer of the OTel end user SIG. I also am a serial blogger. I love writing. And I have a podcast. Now, my day job is as a principal developer advocate at Dynatrace, and I spend my world in OTel and observability. And by night, I like to climb walls, and I checked out one of the bouldering gyms here a couple of days ago, which was very exciting. Home of Adam Andra, or home country of Adam Andra, which was super cool. I also love capybaras because they make me happy.
And I'm Josh Lee. I am an open source advocate at Altinity. For those of you who've probably not heard of us, which is probably all of you, we do stuff with ClickHouse, which you may have heard of. And if you want to talk to me more about that, I would love to hear about that. I am an observability expert at our company, obsessed with OpenTelemetry. In my free time, I have a mission to try carbonara in as many countries as possible, and I am a junior capybara enthusiast.
Love it. So we are all gathered here today because you might be in your organization and you've implemented OpenTelemetry and you're like, yay, this is very exciting, but now perhaps you're finding yourself in the time where you're experiencing growing pains with OpenTelemetry in your organization, and specifically when it comes to managing the costs of your telemetry, the quality of your telemetry, and of course, managing your fleet of collectors, because chances are you're probably running more than 2 collectors in your organization, and you're realizing that, oh my goodness, that is a lot to manage. So what do we do?
Well, we just take the easy path, right? We use auto instrumentation and magic, and all of our problems are solved. We use auto instrumentation, but then we get overloaded. We bolt on tracing after the code has already been written and delivered. This always works out great. We just toss code, uninstrumented code, over a wall and let someone else instrument it, right? Isn't that
perfect.
DevOps?
Great idea.
Isn't that how DevOps works?
Yeah, exactly.
And then if none of those work, we're like, okay, fine, AI, fix it.
Absolutely. Great path to success. Please don't do any of those things. So let's start with the first topic. How do we cut down on the noise of telemetry? Because, you know, I think when a lot of people get into observability, they're like, yeah, we're going to emit everything, and this is going to solve all our problems. And then you realize that now you're basically trying to do an archaeological dig and find that one little precious, you know, nugget of information. And of course, the other thing is it results in increased costs. We end up with information overload.
Yes, like this guy. Boop. So, yeah, auto instrumentation comes with some problems. First one is we get a lot more spans than maybe we necessarily needed, right? For internal operations or file operations or all kinds of things. This is going to vary from between the auto instrumentation libraries that you're using, and they can be configured. But that configuration is going to vary depending on the library that you're using, not just like how you configure it, but even what the actual options are and how they behave, because it's pretty closely linked to the runtime of the language that you're working with. All of this stuff comes with some computational overhead. In some cases, it can be minimal and totally worth it. In other cases, it can actually break your system. So it's something you're going to have to try for yourself and see if it works for you. And lastly, I would say, right, like we're going to talk about sampling, But before you even get to that, if you can filter things out at the source or as close to the source as possible, that's always going to be the best path, both in terms of minimizing the amount of compute and networking that you have to spend and keeping the work closest to the people who should own it.
Exactly. Lowers your costs.
So we can do this intentionally. Rather than sort of auto-instrumenting everything and filtering out what we don't need, we can build up from nothing and do things intentionally. You can just boop this whole one.
Oh, if it would work. Oh, there we go.
Yeah, the whole thing. So we have lots of different ways that we can get instrumentation into our code. I am strongly of the opinion that if you're using if you have an internal library and you can build instrumentation into that internal library, that is always going to be best. And if you're using external libraries and they can have the instrumentation built into them through upstream contributions, that is always best. That's not always possible, and so that's where library instrumentation and instrumentation libraries come in. These are awesome. They use the various mechanisms in the different runtimes to introspect code that was not part of that module and add instrumentation. You can use built-in instrumentation, right? This is just basically no-code instrumentation. This is mechanisms to inject those instrumentation libraries into your code after it has already been built and deployed. And this can work really, really well if you're in a homogeneous environment. Like if you're only using .NET or Java, this can work out great. But if you have a messier, heterogeneous, more typical environment, I would say, this can actually create some challenges as well. And one of the solutions that we are going to talk about to help you maintain these standards across your entire organization is Weaver. And Weaver can also provide an MCP, which can help your AI agents also follow your organization-wide standards.
It does, so stay tuned. Now, before we move on to that, another thing that you might want to look at is sampling. And the idea behind sampling is, most of your HTTP requests, or actually, even more broadly speaking, not all the traces that you're that you're ingesting are necessarily traces that are useful to us. So, for example, a lot of HTTP requests are 200. That's not super interesting to us because
200 OK health check. Definitely
yeah, exactly.
Useful.
Literally, like it's okay. So unless you miscoded your HTTP responses, you're probably not super interested in that. So really, the idea with sampling is you're reducing the costs without losing visibility because you are being very intentional about the types of traces that you are ingesting. Now, as Josh mentioned earlier, you do want to make sure that you are filtering your data before you sample because that, again, it reduces the noise. And that way we are sifting through the more important information. So for example, those HTTP 200 requests, a great example of something you should be filtering.
Yeah,
now,
just turn that off, especially for health checks.
Exactly. And then in terms of sampling, there are, I'd say, two common approaches to sampling. I think there are more, but these are the two most common. One is head sampling, where you basically decide at the beginning of your trace whether or not this trace should go all the way through to your observability backend. And this means you are making a guess as to whether or not this is an interesting enough trace to keep. And then we have tail sampling, where you're basically waiting until all spans have gone through before deciding that that trace is worth keeping. And one of the trade-offs with that is that you do have to maintain state in your OTel collector, which is always really fun. So I'd say it's when you are implementing sampling in your organization, make sure that you have someone in your organization who understands sampling well enough, because it is one of those things that you can screw up, unfortunately.
Yes, don't make your observability team do all of your instrumentation, but do make them teach you how to use these tools correctly.
That is very true, because observability is a team sport.
Yes. That's another talk that Adriana gives.
That is.
And a blog post if you want to look it up. So sampling is deceptively complex. Let's talk about something else that's deceptively complex. Metrics. I love metrics. I think the reason Prometheus has its name is because it like brought fire to the humans. But yeah, they're deceptively complex. Boop. The first challenge we run into with metrics, right, besides the fact that they're not just like numbers and we have to deal with like time encodings and things like that, is cardinality. All of our various attributes, right? Your number of unique time series is your number of dimensions to the power of the cardinality of your dimensions.
So high cardinality is your unique identifier, your unique government identifier. Low cardinality, country of birth.
Yes. Yeah. Great. That's a great way of putting it. There's a new processor we just learned about called the Cardinality Guardian processor. So you can drop this into your OTel collectors, and this can actually help you protect that cardinality before it hits your backend, which is when it becomes really, really expensive, depending on the database or observability vendor that you're using. I would just shout out ClickHouse and some other tools here that can handle high cardinality with ease and can also handle time series metrics, but you might not be using one of those tools, so it's something you want to watch out for. I love the proliferation of Prometheus exporters, but a lot of them include a lot of metrics that you don't necessarily need, so make sure you're not just scraping everything, only scrape what you need. And when we're talking about scraping Prometheus metrics, there's this awesome component in the OpenTelemetry ecosystem called the target allocator, which can evenly distribute the load of scraping Prometheus metrics to a pool of OpenTelemetry collectors.
Yeah, it's awesome. You should definitely check it out. And it started with the OTel operator, and I think now it's actually proliferated itself into outside of the operator, which is amazing.
Very cool.
Yay. Okay, next topic is pipeline efficiency. Now, one of the things that we see in terms of pipeline efficiency is, of course, we know that, as we mentioned, telemetry is expensive, especially when you are crossing network boundaries, because, of course, not only are you dealing with volume of data that causes cost to increase, but you're also dealing with network traffic. And, of course, that makes things quite pricey.
Uncle Andy wants his cut. So, we've talked about OTLP before and how it is one of our favorite things in the OpenTelemetry ecosystem. We absolutely love it. It's awesome. It's verbose, it's rich, it gives us all the information that we need when we're trying to do diagnostics, but that comes at a cost, right? So,
Yeah, come on.
oh, we're having clicker issues.
My clicker doesn't like me. Come on. There we go.
There we go. Okay. Well, so all of that verbosity, right, means that it's a little bit repetitive. We have like scopes and versions and resource metadata that is repeated in every single piece of telemetry that we're sending. And because it's repeated in a row-oriented fashion, we can't use any clever computational tricks to reduce that volume. We can't do delta encoding. We can barely do compression. It doesn't really work because we have variable data types. And then marshalling and unmarshalling all of that data. Well, anyways, yeah, converting it into JSON or protobuf and then back into the in-memory format and then back into JSON or protobuf to send it across the network again. This just uses up a lot of CPU cycles. So in addition to the network cost, you're going to be spending a lot on just computation. And at scale, that can really add up.
Absolutely. So what's the solution? This wonderful thing called OTel Arrow. Now, if you haven't heard of OTel Arrow, today is going to be the day. So OTel Arrow is based on the Apache Arrow framework, and it serves both as a data format, i.e. what the data looks like, how it's structured, and as a transport protocol, i.e. how the data moves between systems. So Josh, tell us a little bit about OTel Arrow in greater detail.
Yeah, absolutely. So it's based on the Apache Arrow project. I love it when open source comes together and works together to solve problems.
Yay.
It is a columnar format. So I kind of mentioned the challenges with row-oriented formats, right, is that we can't do delta encoding and nice compression. Arrow is columnar, which means that each column of data is, each column, right, is sent rather than each row, which means it's all the same data type. So if we have a numeric or date time types, right, like we can do delta encoding, and we can do really, really good compression. If it's something that's repetitive, right, we have compression algorithms that can handle this. And with Arrow, we also even get dictionary encoding, which can be even more efficient than compression for those really repetitive values. Then we get zero-copy data sharing. So because it's both an in-memory format and a wire format, and because it is an open format that multiple tools speak, your tools don't need to copy the data in memory even before, for example, sending it from your SDK to the networking, right? They can just point to the same location in memory and just hand that around, which makes it really, really efficient at scale.
Kind of magical.
Yeah. And right now, you can use it today as a collector extension. And Adriana's going to tell us how.
Yes. So here's how it works. So as Josh mentioned, there is an OTAP exporter. So it applies all that OTel Arrow goodness, and you can send your telemetry data to an observability backend. That can accept OTAP, but that's kind of the problem because not all observability backends can natively accept OTAP. So the workaround to this is you need to add another collector into the mix, basically another collector gateway. I know, right?
Yeah.
And so
there are reasons to do this.
Yes, that is a very valid reaction because that was mine too. So this collector gateway ingests data using the OTAP receiver, and then it'll convert the data back to OTLP. So we see some gains, but I mean, as we talked earlier, OTLP isn't that efficient, so we're not getting the full gains.
But if there's a network boundary in the middle of that picture, right? That's where you're sending terabytes. That's where this becomes worth it.
Now, fortunately, the lovely folks working on the OTel Arrow project do have a solution. There is phase 2, which is the OTel Arrow data flow agent, which takes care of all of this for you. So essentially, it can ingest your OTLP data and then export it as OTAP. Well, I guess it'll export it as OTAP data.
It could be Arrow all the way through, right?
Yeah.
There will be Arrow
it'll go all the way through,
SDKs,
yeah.
Arrow pipelines, Arrow backends.
Yes, so then you have OTel for all. So now we've reduced that extra step, and this the data flow engine was built from the ground up using Rust. So then you get some additional efficiencies from that choice of language
Rust.
as
Love
well.
Rust.
So amazing. So keep an eye out for that. I think that is coming out very, very soon.
Yeah.
All right. So next topic is.
So don't we all love naming things? Isn't
So
this just like
much.
the easiest challenge? Semantic invention is probably one of my other favorite parts of OpenTelemetry, together with OTLP. Right?
Yeah, totally.
So we have a problem, which is managing semantic convention drift. This sounds like I have a sales pitch coming, and I do, but it's for an open source tool. So
This is all an OTel sales pitch, basically. But really cool tools you should check out.
So why should we buy this new open source project?
Oh, well, yes, that's
And
right.
what is it?
Yeah, so there is another open source project you should check out, which is OTel Weaver. And basically, it's a tool that allows us to create, document, manage, and validate OTel schemas and policies. And it's the way it works is basically you define your OTel schema, your OTel schema using YAML, everyone's favorite language. So you define how your metrics look and how your traces look and how your logs look and your attributes. And logs in Weaver speak are referred to as events. And so you not only define the structure for these, but what kinds of valid values, what are some default values. So then your developers can and should adhere to that particular schema. Now, there's also another component which basically you can create some Jinja 2 templates so that Weaver can apply those templates to generate code from your schema. And by code, it can be Markdown, but it can also be application code. It can be your Go data structures. It can be Java classes. Anything that you can Jinja, you can use Weaver to apply to it. And so you use Weaver to basically take that YAML file, apply the Jinja template, and then magic comes out. And then that's only part of the story because also we want to make sure that not only is this documented, but it's also validated. How do we know that this stuff is actually being implemented in our code correctly? And this is where OTel Weaver has a live check option, which during your CI process, you can run this live check, and it'll take, if you're running tests for your code, which you absolutely should, it'll intercept the OTel data. It'll basically check to see if you are following that schema, if you've applied any policy, if you've created any policies as well to accompany that schema. It'll check against the schema and the policies and make sure that your code adheres, and if it basically finds that it isn't, it'll stop the CI process and you have to go back and fix your code. Now, that's a little bit stressful, but fortunately, Weaver does have an MCP server that can help you out with that. I will say I'd say a slight downfall is that for the policy stuff, you do have to know Rego, which is yet another language that you have to sift through. And I don't know, I looked through Rego, it looks a little garbly, but it is the same language as Open Policy Agent, so we are following standards to that effect.
That's good.
Respect.
Yeah.
So yeah, that is OTel Weaver for you.
So does anybody else have like OpenTelemetry collectors coming out of their couch cushions? Just me? Okay. Well, then this might not be interesting to you. But if you do have a lot of OpenTelemetry collectors to manage, how do we do it, right? I mean, even just in my home lab, I think I have like 15 collectors.
Damn, Josh, that's a lot of collectors.
It's bad. Don't follow that pattern. But at scale, right, like you actually have the hundreds or thousands or tens of thousands.
Yeah, and yeah, large organizations will for sure, and that's a lot of stuff to manage. So this is where OpAmp comes to the rescue, and it stands for Open Agent Management Protocol, and it is not OTel specific, although as you may have gathered, it can be used to manage your fleets of collectors. But the nice thing about OpAmp is it was designed with, to keep in mind that you can use this for any telemetry agent. So if you are using a telemetry vendor that has its own proprietary agent, OpAmp technically could be used to manage those agents as well. You do have to essentially turn those agents into OpAmp clients in order for that to work. But yeah.
And if your vendor doesn't support it, you should pressure them to.
Absolutely. So Josh, tell us a little bit about OpAmp clients and servers.
So we mentioned client and server. So we have the server. This is the component that we run somewhere central and interact with, kind of like our Kube API. And it's where we send all of our settings and configurations and get our health checks and all of that, right? It's what we interact with. And then it interacts with all of the clients. And we have one client per agent that we're managing. And the client is responsible for sending telemetry back up, right? Like about the health of the agent, not the telemetry that the agent is gathering, but telemetry about the agent itself. And then also receiving configuration updates and applying them to the agent. And there are several open source server implementations available. You can kind of pick a programming language that you want to try. None of them are official or really like production battle tested. You can also write your own. This is great use case for vibe coding because the specs are there. And no, I'm serious. Like,
yeah, absolutely. And actually, one of the OpAmp servers that was written, there's a Python one written by my teammate, Adam Gardner. And he initially hand-coded in Python, and he wanted to add some more features to it. And he wrote actually a LinkedIn post about how he vibe-coded additional features for it.
Maybe not vibe coding in the sense that some people use that word, but...
Yeah, like I'd say purposeful, thoughtful coding, AI assistant coding.
Vibe typing.
Yes.
And if you do want a production battle-tested implementation of this, bind plane is, I think, the best option available if your vendor doesn't have a solution as well.
Yeah, or write your own because, yeah.
It's
why not?
Beauty of open source.
Yeah. So.
What if I want to use this with my collectors?
Oh my goodness, what a great question,
I'm not using a vendor. I'm using OpenTelemetry collectors.
Very good question, because by default, the OTel collector is not an OpAmp client, and what turns it into an OpAmp client is this thing called the OpAmp extension. And the OpAmp extension turns it into a very bare bones OpAmp client because essentially all it does is it implements the bare minimum capability for an OpAmp client, which is to be able to report its status to the OpAmp server. Now, if you're thinking, well, that's kind of useless, you're totally right, and that's why the OTel folks came up with this lovely thing called the OpAmp supervisor, which is essentially a sidecar or bolt-on that extends the capabilities of the OTel collector to turn it into a full-fledged OpAmp client. So not only does it report its status, but it receives configurations and applies configurations from the OpAmp server. And fun fact, it is one OpAmp supervisor per collector. I learned this the very hard way, where I assumed it was like one supervisor for multiple collectors. Absolutely not. So keep that in mind.
Yeah. Naming things is hard. All right. So this was a lot. What can we actually do now?
Yes, indeed.
Well, first, some gotchas, right? We've talked about a lot of tools. They're all awesome. We love all of them. But they're kind of like, as with most open source things, right, it's a bag of Legos. And Legos are awesome, but they also kind of hurt when you step on them, which is a pretty good analogy for these tools. If you hold them wrong, it can hurt. But they're very powerful when used correctly. So yeah,
Lego.
We do have a bag of many parts that we have to figure out how to put together on our own. There's a little bit of a learning curve, right? Like all of these components, all of this flexibility means that there's some new concepts, some new words that we have to learn. You probably spent like 2 or 3 days talking with the OTel Weaver folks.
I did. I asked a lot of questions.
Well
I asked a lot of questions because I'm like, can you just explain this to me?
Yeah.
It was between them and having very good chats with AI, and then I was able to form a good picture of what was going on. So yeah, but the OTel Weaver folks and the OTel Arrow folks were absolutely lovely to speak with.
Absolutely. And but you could have just read the documentation, right?
Could I, though?
So, yeah, these tools are brand new. No shade to the maintainers, right?
No, they do a lot of hard work.
They're really pushing this forward, but because this stuff is so brand new, right, the documentation can be sparse or not easy to understand or non-existent.
Absolutely. Now, all that aside, what are some of the things that you can do now? I think we've covered a lot of stuff in terms of like really cool tooling that will take things to the next level for you. So with that in mind, what should you do? First of all, look for areas for improvement. That's always a really great start. We want to start small, not big. Don't overwhelm yourself. Do use AI agents to stay up to date with things. I think it's a great way to stay up to date because there's a lot of stuff happening with OTel. I can't keep up, and what a lot of friends of mine are doing, and I'm doing as well, is I have an AI agent that says, tell me what's new in OTel, please make it, from the last week, please give it to me in digestible bite-sized pieces, 3-4 sentences max, and tell me why it's important.
Yeah, and do make sure your agents are using the most up-to-date version of the documentation. The project maintainers have noticed this challenge, and so there's this very useful page in the documentation now that lists the most up-to-date SDK, or not just SDKs, every single component in the OpenTelemetry ecosystem has the latest version listed in this one table. So you can point your agents at that, or you can just use that yourself as a way to double-check that your agents aren't using stale documentation.
Absolutely. The other thing, which I think ties in with the first point, don't boil the ocean. It's very tempting to try to do all the things. You're just going to overwhelm yourself. I usually get very anxious when I have a giant to-do list, and the way to calm down is to just focus on the most important things. Just focus on one thing for starters, and then the other stuff will follow. And then ask for help. And I think reiterating what we were talking about, reaching out to the folks, the maintainers in CNCF Slack for OpAmp, for Weaver, for Arrow. I reached out to folks in all 3 channels as we were putting together materials for this talk. I gave a talk on OpAmp earlier in the year, a very detailed talk, and it was through their assistance that I was able to figure out what was going on and to get them to verify my assumptions.
Yeah, they really want to hear from you.
They do. They want, because they want people to contribute to the projects. They want people using the projects, right? Because if you don't use the project, then what's the point, right? Then we're doing work for nothing. And these are really good, worthwhile projects to check out and to contribute to.
Absolutely. Okay, so in the name of not boiling the ocean, here's just a very simple maturity matrix for your observability with OpenTelemetry. And basically what I would say, right, is unless you have your basics down, these tools are very exciting. But if you don't have your basics already in place, if you don't have things like RED metrics throughout your entire system, you shouldn't even be thinking about these things yet. You should be thinking about okay, how can I, at a very basic level, educate my team and start getting better logging and better tracing and make sure that we actually have health checks or health signals for every service. Then we can kind of layer in more tracing, start to layer in more comprehensive tools and frameworks like SLOs. SLO framework's really helpful, right? And then once we've kind of gotten past those basics, then we can start to think about these more mature things. I would say this third column better, right? This is a really good place for most organizations to be, where you have prevalent tracing, especially for all of your critical paths. You have instrumentation for your Yes, you have internal libraries that have built-in instrumentation. If your organization is large enough, right, to have internal libraries, I think they're great. And then you can use Weaver to provide documentation, right, and help with the education challenges and provide consistent documentation across your organization. This last column, right, this is for organizations that are at truly massive scale. You have thousands of developers, terabytes or petabytes of data going over the wire, and this is where things like OTel Arrow, Weaver live checking become extremely valuable, almost critical at that scale, I would say.
So going back to our original points, do not be tempted by auto-instrumentation overload. Easy to do, right? Because auto-instrumentation is magic, but sometimes it's too magical. Pull back.
eBPF all the things.
Exactly. Tracing should not be an afterthought. Tracing is the first-class citizen of observability because it tells that end-to-end story, and metrics and logs are excellent supporting characters of that story.
Yeah.
make sure you don't outsource instrumentation. And by that, I mean not only to another team as a developer, it is your duty to instrument your code, but also don't outsource it to AI blindly. So yes, of course, it's super useful to ask your AI to instrument your code, but please verify what it's instrumenting, because it tend to do things confidently but incompetently at times. And
Yeah, I found that it's really good at writing tests that always pass.
yeah, exactly. And again, and I think that follows through to the very last point, which is don't let AI fully take the wheel. The human should always be in control.
Can't outsource our thinking.
Exactly. And first and foremost,
Don't panic.
And with that, thank you so much for hanging out. You can scan the QR code at the bottom of the screen it'll include a link to the slides and a ton of resources used for this talk. So thank you so much for having us here.
Thank you.
Thank you for your presentation. We have here on Slido some questions, or one question for now. Everybody in the room who has some question, please put it in the Slido and you can ask it. The first question is, do you have experience with eBGF-based instrumentation? Was it meaningful on its own?
Can I see the question? Oh, no, we can't. Yeah, eBPF instrumentation is great, especially if you don't have built-in instrumentation, or you don't have library instrumentation, or if you don't have any other way to get it in there, or if you're using it as a starting point, it's awesome. But eventually, like if you're writing the code yourself, you should be building the instrumentation into the code and not relying on eBPF. But yeah, if you're using a third-party tool, or just you don't have access to build in the instrumentation, eBPF is an awesome way to make sure you have end-to-end tracing.
Okay, any other questions here in the room?
So when you just try to change OTLP to arrow, then does that make the process heavy for export or receiver?
That's a good question. I'm guessing here, based on limited knowledge, I would ask that question again in the Slack channel. But I think it's probably not that big of a deal, because it's a Rust component, and once you've got it into the arrow format, moving it around between different components is very, very cheap.
Any other questions here in the room or on the Slido? I don't see any other questions. So thank you very much for your presentation, and have a nice day.
Thank you.
Thank you. Okay, I think that now it's time for our another speaker. Another speaker is Daniil Grigorev, and he's going to talk about debugging your Kubernetes cluster in CI, a tale of amateur API server.
Okay, thank you. Hey folks. So, my name is Daniil Grigorev. I'm a senior software engineer at Mirantis. And today I'm going to talk to you about more of a hobby project for me, which I've been developing in my spare time for the last couple of years, and how it can contribute to your CI workflows. We'll talk about the development story, how it led to this point, what you can take from this, and also I can share some very cool use cases you can already utilize in the nowadays AI agent era. So if you want to follow, here's the QR code for the slides. I'll show some demos. If you skip something, don't worry, you can always get back to this. Yeah, so let's start. So first of all, what this project is, I'm going to show this on example. I'm going to start a demo. It's a small, simple tool written in Rust, which allows you to basically take the full cluster snapshot of your cluster and debug it, however you like. So in the file system, you have all the things you need. API resources, all the CRDs, all the things there is. It's not novel thing at all. Like every company uses this in some extent. Some use this in customer scenarios, then they need to collect their logs, their information about their cluster. But they're all partial. The idea behind this tool is to be agnostic and generic. So it works with any Kubernetes cluster and collects the full cluster state, including the logs, including your customer resources. And yeah, you can do many things with it. So here you can see in this demo, I just ran it. I fired it against the current cluster. It's very simple. There's nothing complex with it. Nothing is running. I just removed the cluster. So essentially, imagine a scenario that your CI just finished running the test. It failed. You don't know why. The CI is, well, something very specific. Let's say air-gapped case in some hosted or, I don't know, provider. You have to, if you want to replicate this locally, you have to get accesses to these environments. You have to do a lot of tinkering for that to work. It takes time, but you need to know the reason for the failure right now. And your end-to-end tests may or may not give the sufficient information for you to learn what happened there. What if instead I would say that if you fire this tool in your CI and collect the full cluster state, you get all the logs at the moment of failure, like a failure backup essentially. So it gives you sufficient information and the cluster state for you to debug later and realize what actually happened and fix it. So what I just did here, it's a cool thing. From that snapshot, you can fire up your API server from this exact tool and serve it as a real Kubernetes cluster, as if. For the purposes of these tools, kubectl or K9s, it doesn't matter. They don't think that this is like a snapshot of the cluster. It's a real one for them. So you have the file system where you store all the manifests, and you have this. So pick what you like. So yeah, that was a hobby project I started a while ago. I picked Rust for that development. Honestly, the reason for that was just to explore the language and see how such complex tasks of developing the full cluster snapshot tool and API server on its own gonna break. Or if I find out some better patterns, or it will be actually simpler than writing this in Go, which was always an option. So it's a simple utility, but it's a state machine, essentially. Why? Obviously, I've worked in several companies, and well, the scenario I described to you was very common. We had different CI runs. You get them added by some other teammate, you don't familiar with them. Their use cases are different from yours, so you have to have observability in their cluster state. So I needed something to reliably tell all information about the cluster. Not only the cluster, by the way, because the cluster is just the API level. What you also want to see what happens on your host. So that tool allows you to collect everything directly from like one invocation, including your node level logs, etc. So yeah, it was a really interesting experience writing it in Rust. It was written even before the AI essentially took off most of like development work, or not. We don't know yet, but it helped me a lot to understand how you can basically rely on type system while writing this project, and essentially trust the flow of this language, or how type system helps you to like verify your compile errors to get to the final state, which was really reliable. So historically, I started this as essentially a snapshot collector tool, which would have been enough. Like you have structure in a file system with lots of things in it, files, logs. You don't need anything else. But then, as it comes, since I have developed this like a type state pattern in Rust, I had all the structures in mind. So I decided why not to go further. So yeah, basically it replaces you when you write in Rust some amount of testing you would otherwise have to do to make sure that this like compiles or works. It's not like 100% reliable all the cases, but when you know the end state and what you work with and what's the goal for this project, it's very useful to choose Rust. You know, it helps me. It helped me a lot. Let's say I didn't have to figure out what I can use in this scenario, what is reliable or not. And the ecosystem of that, well, it's a large slide. Start off the Kubernetes project. So since it's Kubernetes to the core, I worked with Kube. Really recommend you to try it. It's a controller runtime alternative in Rust. It is similar to that in many sense. Sometimes it has better features than controller runtime provides. Generics and all those things which in controller runtime are like afterthought. Here are the core functionality of this library, so that actually helped a lot in developing this tool. The difference in Kube, though, is that it's not cached implementation of client library like controller runtime is. So yeah, if you write controllers, they're cached, but if you write just a client, expect this to be direct access to like your cluster, which didn't matter for this tool, obviously, because I only needed to collect all these resources, perform some exponential backoff if something fails, reach to completion, and tell, hey, there's your snapshot. And many other like typical tooling you would use here. For example, one of the reasons I chose Rust and continued with that was Clap. That was really great to work with declarative structures, which translate directly to your CLI flags. And as well as that, if you document those things, like if you write documentation on top of those fields, you plug in Serde, you get the YAML JSON serialization, and that project supports both. You basically can specify a bunch of flags to do the filtering, that's what I'm going to talk about later, some exclusion of secrets, etc. Or you can plug in a simple config, which will be basically saying, I don't want your full cluster, I want some resources from it. For example, your specific project you want to debug. Yeah, so and below there, there's X6 Web. Yeah, it's actually what helped me to develop API server alternative. As you may like get, it's sufficient to like basically reach that state that all the clients like kubectl, K9s are treating this as a real cluster. I didn't want to reimagine the API server from scratch. Like, there's no reason to do that since we have a Golang tooling. It's developed by many people. It's reliable. It's not production-ready software by any means, but for your local case, it's good enough. So, yeah. So never reinvent Kubernetes API server. They all say. So I didn't. What I did essentially looked into this as a data plane. I have all the APIs available. How can I mock this? How can I get those things that would look like a real API server, but it would not be? So yeah, in the process of that, essentially, that whole pipeline became this. So if I collect your cluster, essentially it comes from API discovery, which Kubernetes supports. It actually uses the latest features which were added a bit later than controller runtime. Aggregated discovery, which allows you to efficiently collect all the resources from your cluster, all the types, all the CRDs the cluster knows about. Then it goes to filtering process, where you can, for example, say, I want only these type of resources or only these kinds of resources, maybe some specific name patterns, namespaces, whatever you actually care about in a cluster. Take note, though, in this case, if you come to filtering, you may exclude some of the critical resources for the serving part. But if you only need some partial cluster state and you need it quickly, fire and forget works with that. Collection by itself is just a back-off logic, which performs like get the resource and store it in the writer. So writer performs the storing. Very simplistic, it's a type state pattern, so I didn't have to imagine many things. But while I was developing this in Rust, many things became clear. You have the compiler which checks things for you, and if you declare your model in types, and you use match pattern between these types, for example, you have an enum, it always tells you what's missing. So you have to focus on very small parts of the code, which allows you to reliably write this without any mistake if you're like, hobby project. You don't really want to spend much time, it's not your work. So yeah, API discovery starting like with that. How it dynamically adapts to cluster capabilities. So API discovery provides you in the version 2, which is currently served in Kubernetes, what the resource allows you to query, like what types of things you can do with this. For example, you can get the resource, list the resource, watch the resource, update, create. We only care about the read operations, so get, list, watch. And that's the filtering process which allows us to collect everything, like any custom resources. If they expose this functionality, they'll be in the snapshot. You'll see them in this cluster when you serve it. So yeah, and then I just go through like selection of what we actually need to present to the user, what you decided to collect. So resources, CRDs, pod logs, previous current logs, all those things. So you have all the state from the moment of failure. So that's important to make it quick in parallel, but with some back-off logic, so it doesn't lose the state as much as possible, and your CI essentially is what you had at that point in time. And the CI cluster can go away. If it's expensive, it takes a lot of time to produce, you don't lose anything, right? So collection, as I said, low aggregation. State machines, yeah. I didn't show any code because Rust is just like underlying tooling. The idea here is what it provides. But I used some cool libraries like Bacon, which allows you to basically, well, with Rust, you can extend the type system to some limit with traits. And essentially, that exposes you a way to write a lambda method, essentially like not a real one, but without any arguments, to retrieve this based on some condition in the code. It looks really simple to use, very nice, pluggable, basically drop in and you have a retrieve in this piece of code. Like sometimes even though you write in very low level language, you feel like you write something very high level. So it was interesting to work with. And the writer, which actually became the core benefit of choosing the Rust and this whole pipeline of collection and API serving at the end, because I didn't rely on etcd. I didn't have to go through API server semantics to replace those things. It didn't become complex. I just had a simple type I could extend. And for example, what you'll see later, file system is not only a place where you can collect this. You can collect this in OCI image and serve directly from there. So yeah. File system, though, is very good. Right now, you have agents which can work with your whatever you tell them to do, essentially, probably. And they can read through your file system very well, the structure of a project to understand what is there, what does it mean, how it correlates to. So if you have a cluster with a snapshot and some failure stored locally, it's enough to just tell it, debug it. Tell me what went wrong. There's this cause of error in end-to-end test, expand it. It will do it. I'll show you a demo later. Yeah, and key features is, well, many projects like this are focusing on some partial collection. I decided to pick the full cluster agnostically, but we have to exclude the secret information, sensitive information. Since I collect a stream of bytes of any source of sources, I just put regex, or you can put regex in those environment variable secrets and exclude them by command. So if you want to share it publicly, no problem. At SUSE, when this pipeline ran in our CI, we just stored this in GitHub artifacts. It was sufficient for us to debug the cluster state. We never exposed any sensitive information. Yeah. So it just replaces this as like small 3-star instead of like actual secret. And it works with API server very well, so you don't lose information. It basically behaves as GitHub actions when they see some secrets in the process. You can choose it from local files, environment variables, etc. When it comes to like, yeah, the actual like state, so we talk about only collection. So collection was finished, and that moment when I realized that, well, it works well already, why not continue this further, what I can do? So I decided to reverse engineer API server. That's the interesting part because, well, API server is publicly available. You can always read this code, but it will be quite complex. I'll be basically overfitting myself or my thinking into existing path, how the API server was written, dig through lots of complexity, trying to replicate this in Rust. It's not a replacement logic. I just want a simple tool which works reliably and focus on straightforwardness and simplicities and reliability of this. So that's what I did, and why not to serve it via API? That's the motivation for that. So yeah, as I told you, the whole logic is like type-state pattern, bunch of structures which converts from one to another until they reach the final state in your file system, or they're served back. Because that middle point of the whole collection is reusable. I know what the file came from in the scenario of like collection, and then I know that backwards the same logic applies, the same types. I don't have to imagine anything, I don't have to think for this. I just say, okay, match this against the file. We know that this was selectable, distinguishable, we don't have to think about this. So I get the data structures back for me to work with and like present to you as resources. So all I need is to basically design the API layer, which will be compatible with Kubernetes API. Generally speaking, it was 700 lines of code at the moment of speaking in this presentation. Nothing else. That's all your API server right now in Rust. So how I did this, kubectl is a very cool tool. It allows you to do some very interesting stuff, like increasing debug level logs, and it gives you information to see what happens when you query a resource, when you watch a resource, when you do something with this, like everything is converted to a curve representation of this request, what it responded with, what was sent, what the headers were, etc. So that sped up the process and made it possible for me to start with. So you can just basically look into everything you want. You want to get pods, you get a log. All I needed to do is write the Actix web representation of the path, which will match against those types and basically, well, respond to it in a proper way and collect all the data and serve it back. So the result, it works as so. You can serve it as API server. And I'll show you later how it's capable actually of. Like kubectl is not only a tool you can work with. KNS, I use it regularly in my job. Anytime I return to some previous cluster I had, I don't need to fire up a long-running CI job to create this cluster. I just have some snapshots to debug through and see the differences between those things, etc. KNS is the core motivation for this. But recently I tried Headlamp, which is a UI, open source in Kubernetes 6. And it works with that as well. It's like, it sees a cluster. So in the process, though, the API server is not that simple to replicate as it seems to be. There are many things which are really similar. Like, for example, why the Rust ecosystem exists, because Kubernetes API exposes open API specs for anything they provide. So we can basically generate all the types in Rust as if they were in Golang, and work with them without any desynchronization. So that's actually the core of Cube framework, the KTS Open API create, which generates all the core types, etc., all those things from your cluster to work with. That allowed me to reliably say, for example, that these types are the same what your cluster will see in this version. And it's not going to break. I don't have to work for this. It's just like drop in, forget. Essentially, in this scenario, I realized that like if I get the simple request, like get the resource and return it back, it's not going to be enough. Because, for example, Kubernetes relied on watches. Didn't provide many logs for me to debug. So I had to implement some parts of the API server functionality still. So this open API spec wasn't really sufficient. Like I had to go through, like find out how it works. Fortunately, again, the Rust types, since we have a reliable Kubernetes framework, already provides some states for the watches functionality. You can go through enhancement, caps, which is really good source information. And it's only reliable source information as it turns out, because otherwise you have to dig through a bunch of code, or it's not disposed in the public docs. So the watch behavior was a major challenge, but essentially that allowed me to see how it expects me to return. Again, kubectl helps a lot. Here you have kubectl watch resource. If you increase the debug level, you get the actual events, add, modified, deleted for each resource, what happens at which point, what it expects. You can pinpoint to what resource it actually uses, and then use like reverse functionality in Kubernetes, how they expose the watches, those states. They already present all the states you need. So, but as I said, APIs there, I'm not sure if it's very visible on the slide. That's a section of the cap, which had those things explored. It initially worked for Kubernetes, but at some point I realized something is breaking. My cluster is not served. Even if I serve my like older snapshots, they no longer like responding with anything. I knew why, but I didn't know exactly what was happening. So watches in API server work two ways currently. There is an old model, which was directly watching resources, and there is a streaming list functionality, which essentially a cache optimization technique in API server. I have to somehow re-implement this protocol, but they don't expose how it works. As I said, I didn't want to go through the code, all the issues. It's a whole project, like, let's say, 20 to 30 minutes of my time. So what can I do? I search the caps. And at some point, like, I re-implemented everything. All the types were right. The previous model I applied was working before, but now it fails me. Why? So I digged in and find out this small annotation called KTS initial events end. So the interesting part, so when the watchlist functionality is fired, initially it collects you the current cache state. So a bunch of added events until the bookmark, which says to you that that's the start of your resource version for your cluster state. And later on, that's now, basically, that's what you have right now. After that comes new events, some changes to your resources, right, for the API server. And, well, it expects those annotations, which are only documented currently in the caps, to be present. Once I added this, boom, Kubernetes works. With all previous clusters and current clusters, all the right headers work. That was magical. But it made my head spin a little bit because I was writing some other features, which I'll talk later, about OCI serving functionality. And I was really lucky to implement this at this time because I thought that essentially that will, well, if the time wasn't right, mine approach would not have worked because it broke somewhere in the amount of time when I was writing the other feature. So it might not have been there at all because I could have given up. But I didn't. And yeah, so as I said, poorly documented behavior, but caps worked very well, and add, modify, delete states were exposed to me, so I didn't have to reimagine the logic from scratch. But with that functionality, what I was lacking actually, essentially your snapshot, even if it's read-only, why not to do something like record and replay? Like Askinema I showed you before, they presented this in their demos. You just shell tool, and you collect all the states, like all your shell changes. I could do the same thing with my already established reliable patterns in the logic, but now I only need to basically store the style series and know what changed with the resources when and what. So I introduced this record and replay functionality. You can use it. So it's a long demo, and I can see that there are only 10 minutes. But let me quickly skim it through. So I have a cluster, for example. That's a real one. You can see some CRDs, some things. What I'm going to do is start the recording functionality, right? And we can do some things like delete the resource. And then we can just create the resource again. And things are happening in the cluster, and I store the recording. I stop the recording. We start the serving. And shortly after, you'll see if you always replay this recording stored anywhere in the file system in OCI, it will reliably show you what happened with your cluster. You can go through how it works. It's like a series of JSON patches with annotations for timestamp where it happened. Time series, you basically go from one place to another and apply the patches as they came, as if it was like the old cluster, a real cluster. KNS sees it as a real change in the state, control runtime implementation as well. So many things could work already. If you don't change actually anything in your code, you just only release, get, and watch. So that's it for that. Let me just go back to the slides. What I use it for example, was, we have a scenario where a new CRD resource was getting like 100 generation bumps in a couple of minutes and 1,000 overnight. I was like, what's happening? But I have a tool which can just basically replicate this. I don't see any changes, no reason for happening, like spec is stable. I fired it in. I saw those logs. There were a bunch of patches. I saw the changes in this like application. I fed it to AI. It noticed that the spec was reordered all the time, which nothing was applied, which caused a generation bump. So each time something changes externally, it just goes through the whole loop of applying those things, and you know what happened. I fixed this, very easy to do. It's only machinery which allows this to happen. So coming to the future, and what I'm currently going to present to you already working, it's OCI registry. So the problem with this collection was always that I had to store in the file system the state of the cluster. In CI it works, you can store it in artifact. But what if I want to share it? What if I want to store it for a longer time and debug it later? Imagine a scenario that you have a nightly CI which fails for 7 days. You don't know what happened. Like, you want to know if those failures are similar or different, what's the root cause, fix it. Imagine that you lost all those things, you don't collect this, but now you can actually. You can store it in image, in OCI image, in any registry you want this exposed to be. And you can feed it to AI and say, hey, debug me these clusters. Like, it doesn't know it's not a real clusters, but if you store them through this tool, you tell it to use kubectl, it will basically work as a real cluster with it, and it'll go through the whole state and tell, okay, there's this failure. It's similar as in this cluster, and you get the result. So it wasn't very simple, but here's a short demo of how it worked. So I just created a simple cluster with that OCI image. So it goes through the regular collection, but then it goes to pushing those layers. Initial implementation was very naive to push every resource as a layer, but I hit some rate limiting issues. GitHub Canary Registry has a 2,000 per minute pushes, and this tool was already hitting this with a somewhat middle-sized cluster. So I had to re-implement this slightly more optimized way. It takes much less time than in this demo, actually. You can try it right now. But once it's done, it's finished. We have some things in the local system, as you can see, some metadata for the cluster to serve, like version, etc. But what I'm going to do, I'm going to delete this cluster entirely. I removed this whole folder, so it's not served locally. And I start the codecs with MCP from this ClassGather. And I just tell, serve the collected cluster state from OCI image, blah, blah, and perform the short analysis of whatever happens. And it did. So we started the actual serving. You can use whatever MCP server you want. It's not like vendor lock of anything. You can just basically fire it on backend and say, hey, use kubectl, it's my cluster. Go and just debug it. And it did. So there are some responses from this, some JSON paths it used, which, well, human would probably not ever imagine to do. It works because, well, it's the same logic as an API server byte to byte in this scenario. Label filtering, by the way, if you want to like collect things based on labels, you can specify those includes as well. So yeah, but the AI journey was actually a bit of a new one because it uses kubectl, and if kubectl returns something different for them, AI gets confused. They don't know what's happening. So especially local models, if you try to do this locally. So I had to implement some things. It's another API server story. They expose the printer logic, which allows you to expose your like table output, besides the CRDs, which already have the printer columns, as a like source for this, like how the nodes are exposed. So I had to write it in Cell. And custom expression language also supported in Rust, as in Go. They only plan this. It works just fine already in this implementation. It was quite simple to implement, actually, with some AI help. To speed it up, honestly. It was the first time I used it. And yeah, so it gave me the cluster state engines. Some replicas are ready, something is pending. I can go on figuring out what maybe is missing, but it tells me something. So we can try it out, it'll work for sure. So yeah, and as I said, OCI wasn't working initially. Like one layer per resource was too consuming. So I went to some optimization techniques, like collect the resources as list per namespace, per cluster wide, group them, compress them, decompress them so it doesn't take much time, and basically say, hey, I know each resource as a byte range from this to this. When you respond in like API server scenario, I store this index in OCI image, I give it back. And as an improvement, so it didn't really allow me to serve this state if I had like many resources in the cluster, like 1,000 events from the CI run. It just timed out. It was 30 seconds when I gave it some parallel permissions to run things in parallel. Sometimes it didn't work. Typical 30 seconds, and it was 10 times improvement. It works with same cluster, same snapshot, 1,000 of events. So yeah. Nothing stored is locally, actually. It goes from the image directly to your kubectl. So pretty cool to use, I think. Yeah, the story I already told. And the cell logic basically. And one interesting thing is this UI demo. So I'm just going to leave it out, and we can go to the Q&A session because we don't have much time. That's actually the headlamp UI working on your cluster. So you can do it and try it with your clusters. They're gone. They don't spend any money. They already have finished your CI. You don't know what happened, but now you could. So yeah, that's it for me. Thank you.
Okay, thank you for your presentation, and now it's time for questions. From the audience, do you have any questions? Okay.
Thank you for your presentation. Do you plan to collect kubelet logs, kernel logs, and maybe systemd logs? Do you have any plans to implementing this, and how do you see it might be working?
Yeah, I actually forgot to mention it's already collected in your cluster state. So if we go to those demos, when I served, even in this scenario actually, there is some point when you see like that your cluster snapshot not entirely consistent with what you had in your cluster. There are some additional completed pods. That's what this node level collection does. It executes the commands you specified to it through the debug pod, and you get like per node output for all those commands exposed as pods to debug through AI or locally. So in here, like right now, if we disable this kube system selection I don't know if I actually disabled this, but there's a pod, and that logs were actually from the node level. So I collected the kubelet logs for kind cluster. That's happening by default. You can collect journalctl logs, for example, this way very quickly. It's a convenience measure, but it works already. You can disable it if you don't like. So there are options.
Okay, thank you. Do we have any other questions? Okay.
Thank you for the presentation as well. It was really great to see this. My question is, what about collecting metrics data from metrics API and snapshotting them and replaying them?
That's the future.
Oh.
It's a long-term goal. I
Oh,
actually
I
thought
missed
about this. Yeah, thanks for the question. Great one. Honestly, it doesn't collect anything. It's just purely Kubernetes layer. It started as this. Node logs were like extension on that point, as I mentioned. That was useful and important. Like metrics is another opportunity to work upon. I'll take a look at some point. Right now, nothing like this happens. Sorry, but thank you.
Okay, thank you. I think that now is the time for the coffee. So thank you for your responses and for your presentation. Thank you. So now is the coffee time. Please go outside and have a coffee or wait for another presentation. Thank you. Okay, please sit down. And now we have our another presentation. This presentation will be by Yuri Tosarev and Nuno Guardes. And it's from alert fatigue to self-healing, building an AI-enabled control planes in banking. The stage is yours.
Thank you so much. Thanks everybody for joining today. I'm Yuri Tosarev from Abound. Abound, we are creators of Crossplane. And I work as principal solutions architect as a customer-facing team, so we have a privilege to work together with the largest organizations on this planet and help them with Crossplane adoption. And together I'm with my friend Nuno, who is leading one of such a big organization.
Hello everyone, good morning. So Nuno Guedes, head of public cloud at Millennium BCP, which is a bank in Portugal. Most of our customers, B2C customers, are on mobile devices. So we kind of have interesting things to fix with what you're going to see. And exactly, why did we come up with a presentation that has the longest title? Because we wanted to stop doing this loop with just people, because we wanted to focus on build instead of run. We do a lot of signals. We do a lot of human reasoning. We do a lot of human decisions, and sometimes reconciliation works. But while we're doing that, we are not building the next best thing, which is kind of what we like to do. So we thought, why not do this differently? We are challenged, being a bank, with this topic of operational resiliency. Those of you that work in regulated industries know that there's a big push in these topics. So, a service going down nowadays is a board-level thing. There's EU regulation that ensures that we do a lot of visible, properly managed, auditable, and all of those interesting and very cool IT aspects of the thing. And regulators really ensure that we can withstand, respond, and recover from the sort of disruptions. And having to cover all of this and do build, well, maybe we want to offset that burden of manual operations to something else. The challenge of doing that is matching these sort of requirements from organizations that enforce a service pattern with things like auditability, properly defined runbooks, tile management, alert structure, prioritization algorithms, and all of that stuff that we traditionally would put on humans. Someone said in a presentation yesterday that they had to fill out a lot of forms to get production data. That's a reality, you know. How to do less human and still cover all of those challenges. Even because, I mean, this is something most of us, I think, understand simply. When you do a lot of alerting, oh, we're cloud native, we do observability, we push stuff, we do shift left, we do shift down, we do all of those cool stuff. And then you get 60, 70, 80,000 alerts configured across your platform. And someday at 2 a.m., things start popping up. and the guy that's doing support at 2 a.m. can't handle it, no, obviously. It's all nice and good to say we've covered all of the functional, technical, whatever requirements. That's a different thing to fix it in 5 minutes when it's 2 a.m. And honestly, most of the times, as we might know, it's typically kind of the same patterns. It's new deployments, it's scale issues, it's unavailable zones or regions, or, as we all know, it's always DNS. We need to get this guy a bit more sane, with a bit more tools, with a bit less worries to handle. So, because for the last 6 years, we've been very focused on control planes and implementing platforms and running global control planes, distributing things across many, many places in Europe. It's simple for us to say, let's put that in the control plane. And because we use crossplane, okay, let's use crossplane to help the guy. Crossplane is doing reconciliation loops on most of our infrastructure. The mental hop from a reconciliation loop to an event augmentation loop to an infra validation loop to an information gathering loop is more a mental one than an implementation one. Because if you're checking a resource, going after drift, you may eventually want to do a couple of other things. With this premise, we were very interested in this feature in Crossplane v2, which are functions. Especially because in that scenario where we are pushing 60, 70, 80,000 alerts through pipelines and trying to make use of that to trigger action, the fact that now in Crossplane we can schedule function execution, we can watch for events, or we can even fire one-off functions, means that at the resource context, we can do additional stuff. The challenge with this sort of tooling now becomes, what do I want to do? Where's my trust boundary? Where do I draw the line? I mean, we're a bank, right? Let's not put everything in AI on a first turn. Additionally, the fact that with Crossplane v2, this can be done at the namespace level means that we can do different things for the same resource type for different internal customers. So, imagine that we have different contract levels with different teams. Team A has a very critical service that needs whatever. Team B has business departmental services that don't need to be up at 1 a.m., for instance. Those service levels are baked at the namespace level and are also used when we run these functions to actually determine, do I want to do anything now? Can I wait for 9 a.m. for when the next guy comes into the office and can fix it with a bit more time, for instance? And mixing these two things together means that we become more efficient. We don't take the guy out of the loop. We choose and help him do it a bit more efficiently. So, Yuri, do you want to show what this means, and then we'll drill into actually the how of it?
Yeah, let's try it out live. And sorry, I'm gonna sit again as yesterday. This conference spoils me. So let's see what it was. Hello. Am I hearable? All good? I don't see terminal because okay. So maybe first thing first. Who is familiar with crossplane in general? Nice. Who is familiar with crossplane V2 capabilities? Pretty cool. And who is familiar with V2 operations and operational functions? Nice. So the demo gonna be useful. Thank you. All right. So what we have first? We have three Azure caches deployed as a custom abstraction for the bank, right? One is just for end-to-end test, and two are going to be our demonstration material. The implementation is not super important. It's like Azure cache with associated networking resources. It's not the main core of the story. So imagine like it can be any other infrastructure primitive. What we're going to use for injecting AI-enabled operations is a new thing called operations and operational functions. So what we are running here is a set of watch operations that are doing like a different stuff. Cost analysis, resource diagnosis, optimization, remediation. We will go through them gradually all together, step by step. So if you look at the associated operation YAML, right, so what to look at? Cross-plane watch operations is new V2 resource. It's going to watch the specific resource that you specify. In this case, we specified the cache, again, custom abstraction for the bank, and we're matching the labels. So it means that on a cache custom resource, on a composite resource, there should be a label to activate its operation. So pretty straightforward. And within that operation, we are going to use a bound function OpenAI that is capable to operate in operational function code path. We have a composition functions. You remember like that composes a standard set of resources, and operational function that can act within the operational scope. So in this case, we are using OpenAI, and just in case we comply with the bank regulation, and we are running custom OpenAI endpoint within Azure. So that's how we integrate, and we actually not sending a direct request to anywhere. So it's a very fine-grained, kind of almost, from Azure standpoint, air-gap deployment, let's say. We have a system prompt, and we say to this operation, like, you are resource diagnostician, and you're going to take care of Azure Redis platform, and we have a pretty verbose user prompt, like how you can how this minimalistic operation, AI-enabled operation, should act on the specific resource, and what it should do in case of different scenarios, right? And the important part that it is able to patch only this specific cache that is selected by the associated watch mechanism, right? So we have this thing in crossplane called required, or formerly known as external resources, and this way, this AI-enabled operation is super safe. It can act only on the cache and can patch the associated cache resources only. So that's roughly how it works, and we can see it in action right away. So once again, we have a cache. We have this cache that is stuck, right? So we can get this demo stack cache one. We'll pop it to a queue for visibility. So something is happening there. And for the integration, remember the watch operation, the AI enabled is there. So it means that watch operation will be triggered whenever the resource has some event or update in the spec. So I have an associated wipe-coded demo script that can help me with the demo flow. So before we have a stack resource. We can use a kube control, as I did, to look at it like, what is happening, and we need some operation experience to figure out what is wrong with that resource. But if we use AI, and I will use a demo after, then we can see that there is a special annotation that was already set by the AI-enabled operation in this case, and it has a diagnosis, right? So now we know, like AI figured out for us some internal knowledge that ARD IDs should be actually properly set. So once again, we can look at the spec, right? And yeah, ARD is missing there, and there is an associated diagnosis annotation is around, right?
Let me just add one thing.
Yeah, please.
So the guy at 2 a.m., when he connects to the cluster and does get, he already has a message telling him what's wrong. He's not going to do diagnostics. He's going to validate SVRs. He's going to fix it. That's stage one.
Exactly, great point. So in this case, we have like the form of this intelligent assistant. So it's effectively kind of read-only mode. It just sets the annotation on a cache spec. So it didn't act on it, right? So we have advanced version of the operations that can actually auto-remediate stuff. So the principle is simple, is very similar to the first one. Watch operation, match labels enabled, and it also filters for allow auto remediation true, so we are in full control. So if we don't want AI to act on that resource, we just skip this label. And if we look at the prompt, right, the same function OpenAI, system prompt, and we just instructed how to modify the resource in the specific set of in the specific context and how to patch it properly. And again, it has a cross-plane integration, how to return this set of required resources and what associated engines should do afterwards. So, okay, let's go to the remediation stage. And to remediate, what we need to do is to set the label, right? This enable auto remediation. So my script is going to set the label on the resource, and effectively AI operation got immediately triggered because it's watch operation, it's watch for the associated change of the resource type, and the thing was auto remediated, and it puts this audit annotation that it did its job. We can obviously, and we should, double check that it's true, and we can double check the auto remediation annotation, and we can double check the spec, and we see that ARD ID, this internal identifier, was properly fixed by AI in this demo mode. So now it will take some time, but it will reconcile itself, and it will be fully fixed, right? So that is example of automated intelligent assistant and intelligence control if we want and allow AI operation to patch the spec. Now, based on this pattern, we can do some interesting stuff like cost analysis, for example. So in this case, we have another demo costly cache, right? And before AI, what we can do, we can check the spec, and in its spec, we will see the SQ of extra large, and we don't know as an operator, is it justified or not. So we need to get this knowledge somewhere, maybe from the wiki, maybe call Nuno, right, and ask if it's reasonable enough. So we have to do some work. In case of AI, we have a helper in the form of another set of AI-enabled V2 operations. And now when we trigger it by setting yet another label, of cost analysis, we telling the operation to react, and we getting this cost recommendation. So if we check the cache, which is demo costly, right, we get the YAML, we pipe to a queue, and we check what is going on. All right, so we have a cost recommendation. Again, it's a read-only, right? So this intelligence assistance patterns that it's not acting, but just recommended via annotations. And we have a spec that is SQXL. Okay. So we still running extra large, but this AI machinery says, like, it's better to downscale to save some bucks. Let's do it, but not manually. We have another operations that can do the optimization for us. So we tell it cost optimize, we set in the label for allow cost optimization, and it's gonna patch the spec accordingly. So if you double check that stuff, first thing first, we checking if the cost optimization happened. So patched from, it's actually proceeded, right? So it went from XL to L and to L to M according to the prompt. Now it's already patching, downscaling to the next resource size, instance type. And it works exactly the similar manner. If you look at the cost analysis, this is read-only one, right? So we're matching the labels and we're telling the prompt how to operate it. Here we kind of hard-coded the logic, right? But we can theoretically get it from some external resource from the bank, right? How to imprint the logic. And for cost optimizer, that's the one that is reacting to the LO cost optimization true and actually enables enable to patch the resource and modify the SQ target. So that's it for the demos. Just a quick recap. We went from intelligent assistant to intelligent control, and we have a specific use case of cost optimization also utilizing these two patterns, right? So it's just an FAA, as you can inject only required prompts into these V2A operations. You can use function OpenAI, in this case. We also have a function cloud. If you have a local model with OpenAI endpoint, it's also possible. We have a webinar around it. So it's very integratable, extensible, and you can apply this pattern in many situations. And the most important part is that you can test it. And whenever you trust it, you can promote the assistance to control, and everything is under your operational spec, operational knowledge, and you have a minimal amount of surprises when you testing these patterns, these operations and prompts gradually. So I think that's it for the demo. Nuno, stage is yours again, and slides as well.
Quick comment on that last scenario. That's called cost optimization, but if it's looking at connections and memory consumption metrics, you could also call it right sizing, because it scales down, but you can also scale up, obviously.
Yeah, you want to recap on that slide, like what happens there, right? So
yeah. So we are gradually moving from what's in the slide called stage 2, intelligent assistant, where we put a lot of annotations on resources for people to know what's happening instead of having to go at it, to, in some cases, fixing stuff before you get there, like on the remediation story. So operations that we think are not too critical, probably you don't get paged, or if you do, you're validating the fix. And finally, right sizing, both on scale-down stories and on scale-up stories, is something that's pretty relevant. It's faster to have a watch operation do that for you than getting someone to connect, to check, to scale. So basically, it's around bounding AI reasoning. We are not using big models. We are using small models. We are using those models with small contexts. Exactly what's defined on the watch operation, and it's being triggered by the same control plane that's checking resources. So reconciliation and operations end up being also done by the control plane. Of course, you've seen in the demo a simple way to keep evidences. We have to be a bit more complex than that to actually have the proper auditability trail, but the story is around this. And so, how do we keep it safe? Schema bound. We don't let AI run along the cluster and get whatever it wants and do all of that. No, we scope the problem before passing it on to some LLM, or in some cases, SLM. Policy constraints ensure that even if something wants to step out of the box, it gets denied. And we have no issues with starting small, because we think the story of providing information when you get to the resource is already a pretty powerful story. Having a best guess on the root cause of something is pretty valuable. And of course, audit trails, that's our life. And why do we look at local models, small and large? There's a whole sovereignty story, sure. But more than that, cost efficiency, latency, if we can keep if we're supposed to keep the service up for us, the models are just another service that we have to keep up. It's cattle, it's not a special thing that we subscribe somewhere, it's just we have the hardware, we run the things. It's an upfront cost instead of something we have to check every week or every month of how much tokens we're spending wherever. And of course, you've seen the speed of the watch operations. That's really faster than having someone get into the cluster and do things. That's faster than having an event-driven automation outside of Kubernetes. That's faster than cron checks that we would typically have before this. So, what changed? We can talk a lot about what changed, what are the results and all that, but I think the most significant thing is people are less afraid of connecting to an issue. When you get an event and you need to fix it, you need to diagnose and fix it, people are less afraid to connect because they expect the context to be there. It's not like you don't have to think for sure. No, you have to look at it, be aware of your business knowledge, IT and all of that. But you have the rest of the context there. Sometimes these operations are designed just to add additional information. But that beats you going after stuff. So, start deterministic, put boundaries in there, keep it small, by choice, not by cost or whatever. Do watch triggers instead of pulling. Run it locally if that's your story, if your market, if your business supports that. And proof changes. This, more than a story of implementation that's now enabled with functions on Crossplane v2, it's more a story of shifting value. Sorry, it's always this sort of thing, but it needs to be said, because as soon as we started showing how we were fixing stuff faster, a simple prompt, that enabled a lot of cool stories after this one, and this is important. So what's next? Sure, more. No, let's do more resource types. Let's do more complicated decisions. Let's do more stuff in general. But let's do it a bit more fine-grained and improve, for instance, that story of supporting different customers in different SLIs and all of that. So the takeaway that we would like you guys to, well, take with you is this one. It becomes safe in production when it's governed, it's bound, there are guardrails, and it's auditable. We have no issues running it like this. And there's code if you guys want to check it out.
Thank you so much.
Okay, thank you very much. And we have some questions here.
Got to read it.
The first one is who gets fired when auto remediation deleted prod database?
We don't delete databases.
So you're saying when it happens, it just shouldn't have happened.
No.
It cannot happen in this scenario.
It's impossible to delete databases.
GPT has killed, has led several young people to suicide. You're saying that it just should have better guardrails.
Yeah, so in this case, VV2 operation has a very constrained abilities to do stuff, right? So it just doesn't have an ability to send the deletion verb because the core deterministic part will not accept it. So that's the core of it. It's just like even if it want to, it wouldn't happen. That's it.
And on that one, there's an additional guardrail, because if you actually are able, even as a human, if you're able to send a delete, what the cross-plane composition does is it just removes access and doesn't delete the database. Because, man, who wants a database deleted, right? Leave it to a human.
The question is, this has already happened. It's a fact.
Mm-hmm.
Not with crossplane.
But to your point, you know that very famous sentence that says computers don't get blamed for management errors?
I wanted to add this sentence, and it says, victory has many fathers, but it defeated an orphan. So
Yeah.
who gets the blame? Who ends up with the bag?
It's always...
I will rephrase it. Do you add an owner to the service, or who's responsible into the metadata, or it gets decided who's fired?
It's always the service owner.
Okay, service owner.
No service is owned by anything else than a team of specialized people. And if they want to use AI, sure. If they don't feel like they can use AI, sure as well. They need to find out other ways to implement the service. I'll read the other one. Does the cost optimization operator provide any benefit for situations where HPA VPA can be used?
I think I know who asked this question.
Yes. But there are a lot of different answers here. If you're just doing plain vanilla HPA, for instance, sure, yeah. But maybe you want to use CADA for that, and you want to touch the CADA resource instead of just doing standard HPA. If you're talking about cluster scale, yeah, but maybe you want to use something that has a more complex logic than a LLM to do a cluster scaling. Is it possible? Yeah, sure. But no, pick your poison.
Yeah, and the important point is that we don't want to replace the deterministic logic like CADA provides, right? So it's like it's amending the probabilistic decision making to the story, not definitely replacing it. So you can mix and match.
Yeah. And another question: when remediation does direct changes to a Kubernetes resource, how that matches with whatever you use to define the desired state somewhere, GitOps or other? Yes. Welcome
We get
to
this a lot.
GitOps hell. Well, again, it's a matter of visibility, at least for us. That's the best we can scope it. So if you auto-remediated something by changing its definition, maybe that AI function should pause that flux reconciliation, for instance, in our case, but in a way that someone at 9 a.m. has a message to fix it. Someone needs to do a PR if that change actually made sense, but no way AI is going to be approving PRs, sorry, no. We have someone fix it afterwards. No, service is up, issue is mitigated, let people clean up the mess afterwards.
Yeah, practically you can skip this desired field from the like relaxed in a GitOps scenario. And also you can teach your function, operation function, to create this PR, not approve, but create. And then you close the GitOps loop as well in an automated way, if you like.
Okay, guys, thank you very much for your presentation. It was really interesting. And now we will have another presentation. Thank you very much.
Thank you.
So thank you everyone for coming. 1 minute. Okay, so no 1 minute. We can start. Maybe one day you can see my slides. I know here is only one screen, so if you have questions, please, on the right side, you see wonderful QR code, okay? And then we can start, okay? Hopefully you have it, because I like questions. So, why I'm talking about this stuff, about some credentials, about some secrets, right, when you can get them? Because I've been there. I'm the guy you can see there, guy in the trenches. I've been through all the fancy stuff. I've been through the mud. I've been through the blood. I've been through like literally everything, sweat and so on. I'm dirty. This is not theoretical session. Okay, this is practical session. What I've seen, what I still see, okay, and how to get better. Okay, and again, I'm not selling anything. It's just for you to know and how to easily, hopefully, fix it. Again, there you can see Big Bang, right? Also, you can see there are some non-profit organizations and another stuff like Java User Group, Luno. I've seen this issue everywhere. That's important. Small companies, big companies, does not matter. There are developers, there are these issues, and we can find some of your passwords. Yes. So, why it matters? Maybe you heard, oh, there is supply chain attack, right? Some sophisticated attack. We need AI, you know, and it will go through, it is called mythos, right? You've heard of it. We need that. Maybe, but maybe you can just, you know, get your password and try it with it. Nothing else. So that's quite straightforward. And according to statistics, 70% of breaches start with your own credentials. It can be token, right? It can be SSH key, whatever. So this is dangerous and it's very common. Be aware, according to new statistics, when are you using your chatbots, you double the risk that your credentials are in plain text. Double the risk if you are using chatbots. Because they are fast, effective, right? Please, just run it. Yeah, you will see how to get all your passwords. So, I will be talking about how to prevent this very easily without sacrificing, if you heard it, developer experience. So, I don't want to take your keyboard away. Okay, if you have security in your company, like I have, they are not happy with me, and they would like forbid me even access to computer, because that's the security, right? This is their job. So I will show you, hopefully, how to do it without sacrificing your comfort, let's say your speed, how you develop. Okay. We will be talking about 4 main points. One will be your desktop. In this case, I will take a look at Maven. Okay. Then we will go through Git. Probably you know that the most. Then images. Maybe we'll learn something new. And the last one will be CI/CD pipelines, because they are the most difficult to get rid of the issue, and I like it the most. Okay, as I mentioned, Maven. So, hopefully some of you are using Maven, right? Is someone using Maven? Someone, please, please, please. Oh, half of the, okay, so half. Then, you know, there is setting XML. If your company is a little bit bigger, you have your own Artifactory and you need your password. So what I did for a long time, I just put some credentials into my settings XML, right, into my local machine, and it was there. So, okay, who cares? It's just my, you know, local configuration file, so I'm safe, absolutely. Yes, but 2 things. First, if you are something like senior, lead developer, people often come to you and they will say, please, Martin, I cannot make the build. Can you send me your settings XML? Hopefully you know it. And then you need to be careful, because you will send it with your credentials, and mostly these credentials are your domain credentials. Well, I would say mostly, yes. So then your colleague knows how you log in into your computer. Oh, I can do it instead of you. So that's very dangerous. And the second thing is, if you are doing it on your local machine, it's very likely you will do it in your CI/CD pipeline. And when you try it, don't worry, I will zoom it in for you. If you try it on your CI/CD pipeline, you can get all the information from your pipeline, from your technical users. Okay? Why is this dangerous? Technical user, right, in your pipeline. Mostly, it is access not only to say Git, but also to Nexus, if you are using. It is access to some of your Confluence, maybe Jira, maybe, I don't know, Argo CD, right? It does deployment. Maybe there's access to other systems. So I get this password, I can go everywhere, right? And that's not all. Even worse, if it is Maven or Gradle, it's the same. This user has access to Nexus or the Artifactory. So you can even have pull requests, code reviews, everything. But now I have access to your Nexus. I can upload to your Nexus what I want. I can do it. Okay? And you will deploy it instead of me to production. I don't have to have access to production. I just upload something to Nexus, and I wait, and now I have access to your production. I have all the data. In case of bank, right, I can send money where I want. I can install anything I want. So this is why it is so important to pay attention. Okay? One small misconfiguration with this one, and I can deploy anything I want. Very difficult then to prevent. Okay, before I show you the next, please some caution. I will show you a lot of things how to get the credentials. Please be responsible adults, okay? If you want to try it, consult it with your boss, with your security manager, or don't do bad with it, okay? It's like a small nuclear bomb. You get all the passwords, okay? Please be a responsible adult. So there are two ways how to get it from Maven. First one, that's simple debug. You just turn on debug, and in older, it's important, in older Maven versions, you have a header when we are connecting to Nexus. And in the header, there is authentication, and then there is this field, and you can just copy-paste it. Because it's debug, oh, I was debugging something else. I'm just sorry, I didn't know there is a password. No one can say to you anything wrong about this one, right? And the second one that works in every Maven, this is a little bit more straightforward. So if we are doing this, I would say that's attack. Okay, but still, we have it, you can try it, and if you try it, you will get something like this one. Right, that's my local Maven, and you can see you have my password, you can log in and do whatever ugly stuff you want to. Okay, that's normally, this is the output, okay? When I was talking about different Maven versions, you can say, oh, but I have the newest one, right? And I'm okay at least with the debugging. Maybe, but maybe your company has ability to turn on any Maven you want, because some software is still using old Maven, right? Okay, so I will go with Maven 2.2. What do you think? It's fixed there? No. So yes, that's really difficult. Now there will be the better thing and how to deal with this. And I like this one. It's 5-minute fix. Guys, 5 minutes, and for the rest of your life, you don't have to care. I like this one, okay? There is something called settings security XML. Okay, one more file. You just put your master password there, okay? And then you generate another password, right? 2 commands. Copy-paste to secure password to the security XML, and you will be happy. 5 minutes, guys, again, 5 minutes of your time, okay? You can Google the precise how to do it, copy, paste, and that's it. You are absolutely free. When someone will ask for the password, as I did before, everything they would see is, maybe I will try this, Steve. Yes, they will see this hash here. So they can get the hash, but that's nothing for them. Just hash, okay, good to know. Please don't share settings security XML, okay? It has security in it, okay? Don't share it. But again, it's much more complex, right, to share this file. So this is Maven Fix. Again, if you can do anything from this session, this is the fastest thing you can do, and you can do it especially for your pipelines, okay? Just like today, tomorrow, just if you have a laptop, try it, whether you can find the issue in your environment. Easy, really. Okay, so as I mentioned, text credentials, again, there is nothing bad. It's very likely that someone can find it, okay? And the impact is crazy. As I mentioned, I can upload to your Nexus, you will deploy it instead of me. I don't need some rights escalation, right? I don't need nothing special. I will just directly push to your Nexus. No PR, right? Nothing necessary. So this is really, really severe. Fix, 5 minutes, guys. Again, 5 minutes. Easy. Okay, next topic is Git. I hope everyone is using Git, right? And if not, then probably some colleague of yours is using. And mostly you heard about that one, that if you commit something, it's there forever. Okay, I will show you why it is so bad, okay, and what you can do. So question is, who, please, at least once in their life, pushed, that's important, pushed some password into the Git? Again, I like you. Okay, this is the audience, almost everyone. Almost everyone, yes. There is only one way how you can fix it. Change the password. I will say it 6 times in this presentation. Only way you can do is changing the password. Once you pushed it, you can change, you can do revert commit, you can do some branch crazy stuff and so on. Don't. I spoke to some guys even, they realized that they have a lot of passwords there, okay? And the issue was that they took entire tree, removed the passwords, and created a new repository without history. This is a possibility how you can do it also, but still change the passwords. So I will take here, hopefully this will work. Yes. So here is the command, how you can find it. There are a lot of tools, but again, I like my command line. The salt in the injury is that the Git has grep command. So Git will help you find your passwords. You don't need any sophisticated tool. Just grep password, okay, and you will see how it looks like. That's it. You can grab, I don't know, credentials. You can grab token. Try it in your repository. You can do it now. Not now, please, after the talk. Okay, after the talk, please try it, and you will see how many passwords you will find. I've tried it with 2 different teams. One is Mature. This is the result, okay? You see that environment variables, so this is nice, okay? And the second slide with a little bit of not Mature team. They are new to the company, to the bank, okay? And please, before you try to use all these passwords, they were changed, okay? Everything in this presentation was changed, including email addresses. I had to go through 6 people, to approve this. So yes, it should be safe. But this is when you know it's bad. Again, please remove the password, do the correct stuff, and change them. Change the passwords. I know it's pain. This is not as fast, changing all the passwords, right? You need to go to somewhere, change it to your database, give it to everyone, and so on, but that's the only way how to be safe. Why I'm telling that? Because imagine you are in a bigger company, you have externals, right? And there is some external, let's say from North Korea, for example, and they have access for 1 week. They grab everything, right? And then who? How can you prosecute them in North Korea? And I'm not making it up. Ask Amazon. They know, and they actively search for people from North Korea, China, and so on, whether they have access to your system. It's based on the typing, how you type and what's the latency there. But different topic, it's not unreal, okay? You just need someone in first 3 months and they can get out with all your passwords. That's attack surface, right? You start with that one. So again, please be careful and do it as the major team did, okay? Again, changing password is bad. If you don't see it, that's okay. I will read it for you. This is what I found with another team. And you have VM configuration with email address, probably domain password, access to the third party. There is some token. I think that's good enough, right? So I can now, connect to the third party and pretend I'm a big bank. I can do anything now. I can do the really ugly stuff. So again, you can say, oh, that's only dev environment or testing environment and so on, but maybe your technical user is the same everywhere. Maybe I'm not suggesting that stuff. Okay, so that was about it. So what to do? Please change the password. Always change passwords, okay? 4th time. Then you can try to properly clean up. There are some commands, but once you pushed it, it's too late. Someone can pull it to them. Okay? If it is your local machine, rework the commit, fine. But once you pushed, change the password. Everything else is not enough. Okay? And of course, please remove it and use, as I showed you, environment variables. That's really, really important. Okay? Next one will be about a little bit, it's not about Docker, but images at all. Okay? So there is one stuff when you want to configure your Docker image. Mostly you need some connections, right? You need to connect, for example, to your database. You need to connect to some proxy to download stuff, something, right? And there is one thing, your layers, they don't remember. Okay? They will always come back as zombies. They will haunt you. That's very, very dangerous. And the best thing how to do it is maybe to show you. Okay, so I will have one hand for this demo, but this should not be so bad. And if I go here, imagine I have a where is it here? Give me a moment. Yes. I have something very small. Okay, I just building a template. You will see the details. And I put a file there. And what you can do, there is a tool called Dive. And the Dive can show you all the Docker layers. Because maybe you ask yourself, why is my Docker so big? Right? I copy one file, I deleted it. But the image is still big. And that's because here, in all these layers, it never forgets. The layer is there forever. Okay? It's not like you delete the file and it's deleted. No, it's deleted here in the latest one. Right? Here it is deleted, here it is copied. And you can always get there and see it. Probably you now see that in the temporary directory, I copied secret properties, and in the next layer, I deleted it. Right? This is very easy how to find it. Okay? I can find. Unfortunately, Dive does not have a viewer or some file editor, but I will show you how to get it. How else? And again, what is ugly? You don't need to install anything. As you see, I can run Dive from container. No installation needed. So that's, again, bad for security, guys. And here, when I go a little bit here, you can always download your file as a tar file. Every image can be downloaded. Just simple command export. You have it? Yeah, I didn't show you, sorry. here. And I have the image downloaded. Okay, there are every layer is one tar file. Okay, and I found the one where you have our temporary secret. Okay, so if I go there, yeah, and if you can see, okay, doesn't get any bigger, but I think you can see the password. I can find anything. So, for example, if you copied your SSH key, maybe I can get your SSH key. Ooh. So I'm very dangerous then. Okay, anything. So again, Docker layers, they don't forget. They are there forever. There is nothing you can do. Oh, there is. I will show you. It will be, okay, I maybe should not go there, but there is one more step you can do. I don't know how deep you are in images, but there is always this manifest. What did you do, right? I copied, I did this and this. And sometimes some guys, they will write the manifest with, hopefully you can see that. I will try it. That's too weak probably. But here we have Nexus password, right? Nexus user. Oh, when they put it to manifest, there is no help, okay? This is what you cannot prevent. You can just teach your people. Please don't put it publicly on the internet. But yes, this happens in big companies, in small companies, everywhere, okay? So how to fix all your builds and the copying files, right? Two possibilities. One is mount type secret. So you're mounting files as a secret and you are good to go. Disadvantages, you have to do it everywhere. So if you have a bigger company, you have hundreds of pipelines, good luck to telling everyone and to monitor it. There is second possibility, two-step build. What does it mean, two-step build? Here, the first part at the beginning, that's just building your image. As before, it means copying this secret. And the second part, all we do is just copying from the builder, okay? And that's it. There will be only one command, copy your jar file, and that's it. You can do this with everything. It's easy to implement. Again, it's not 5 minutes, let's say 1 hour. But if you do this, all your history is forgotten. You have no history of your images. Maybe it's good, maybe bad, but it's a really good fix. And some of your images then can be smaller. That's also an advantage, right? If you copy some files, this will forget everything. You just copy your jar file. Okay, so very good to do, and not a lot of people know that this is possible. Okay, so please again remember images. Remember, okay, there are layers upon layers. And what's important, 30% of all Docker images have this issue. 30%. That's a lot, okay? Remember, two-step build. Easy to implement, very fast results, and you don't need to control all the teams, whether they are doing it correctly. At the end, you just do second step, please copy jar file. Or it doesn't have to be Java, it can be something else, but it's the same logic, okay? So my favorite part, and that's CI/CD. You know, this all started when some operation colleagues wrote me a lot of times, Martin, we forgot the password. Do you know how we can get it? Because we want to reuse it. And I, okay, here you go. And then again, Martin, we forgot this password. Can you get it for us? Yes, again, it's a real life. Okay, that really happens. And then, when you look at your pipeline, details are not important, okay? In our pipelines, we had 60 parameters because we inherit, right? We are some team, we inherit from some cluster, and we inherit from the organization. So we inherit all these passwords, secrets, connections, everything. Yes, and you can get it almost for free. So guess what? We have demo time. One hand demo time, okay? So I'm not showing you TeamCity, I'm not showing you Jenkins, it's almost the same, okay? But I'm showing you this fancy stuff called GitHub and GitHub Actions. I think that's like standard, right, for security and everything. Okay, so I have here 4 jobs. Ah, wonderful. And maybe a lot of you tried doing this easy stuff. My secret is, right, just run it, echo. And here is what you get. Oh, GitHub is so good. I cannot get it. Okay. That's okay. So what next? There is something you can do. You add this fancy command at the end. Now the masking is not working, and you have base 64 of your password. Just put it to some public translator or use your command base 64 to decode. Here you go. If there is any security guy, they might take you the command base 64. And yes, I want to be kidding, but no. Because, for example, we were taken tar command for the packing and unpacking, right? Because it was unsecure. Yes, then we realized we need it for network communication. Yes, but this is why I'm telling about you this, because if you take me from keyboard, this is not good, right? And even if you take me, okay, base 64, okay, oh, it's out. What can I do? Maybe I can use this set command. And what does it do? You know, I'm just writing one character per one line. Good luck with masking. And I can be more creative, right? So here, what's the password? KCD CZSK is the best conference. Ooh, okay. Hopefully true. And this is my password. I don't need any base 64, nothing, right? Not possible to prevent. I don't see any way how you can prevent this, okay? So we will see what can be done to negate this issue, okay? I will be a little bit faster. We have some slides, the rest of them. Again, if it is production, please check your pipelines, whether there is something like this. Yes, you can just check them, whether someone wrote small set somewhere. And of course, if there is echo, that's maybe an issue. Okay, so scan it for echo. You can find plenty of tools, right? This is like what you can do. Use AI, use whatever you want, but this is one of the things. Also, if you are writing it for ICE, so it means 2 people, okay? Do that, that's also good, because otherwise someone can use it. And before the question will be in the discussion and questions, the only thing how you can really prevent it is this OpenID Connect. It means short-lived secrets. But this is very difficult to implement. It takes some time. Okay, if you have short-lived secrets, you are good to go. And if they know your password, it's valid only for 1 minute. So, okay, I'm good with it. But otherwise, yes, CI/CD pipeline is the worst. What you can do, for example, is Vault. Right? Someone mentioned HashiCorp today to me, so you can do your Vault. And this is configuration from Spring Boot, because I work in Java. And that's all. Now you get all your passwords from Vault, and they are not per se somewhere stored. So if you can, do it, at least they are not in the plain text. Okay, they are not in the plain text, but it's better, and it's not so difficult. I will try to sum it up, so we know where we are, okay? Some best practices. The issue is plain text. Literally, for me, the biggest issue is plain text. So please make the Maven, right? Check it, please. That's not so difficult. Encrypt, okay, everything you can. So if you have your some vault, whatever, encrypt it. Only some people can use it, okay? Again, Maven, 5 minutes, guys, 5 minutes, right? You can do that. Then plus use modern tools. For example, we have Kubernetes secrets, HashiCorp Vault, but you can use any other technology, or some cloud configuration. It also helps, because your passwords will not be in plain text, okay? It's the same about the Maven, right? You only get hash, that's good. I'm happy with that one. So guys, that was all from my side. So thank you for listening. And at the end, if you want it, you can find me here, give me questions, or you can scan the QR code and get all the information. There is my presentation, and there is a repository in which you can play. You can try searching for passwords. There are the Docker file. You can build the leaky and clean Docker. And I have other stuff, but for example, how to get it from memory. So thank you, guys.
Okay, thank you for your presentation. Now we have here some questions from the audience over the Slido, and please, you can ask them.
Yes, one, thank you. What if I push my password into a branch and delete the branch afterwards? It's still there, because branch is only reference to the commit. The commit is still there, and the reference is only removed. I can show you in your computer if you come to me after the talk. Using Vault, the way shown on the slides, security with plain text, a token to access all secrets. I feel the impact would be similar, if not worse. Yes, but it depends, because in theory, the access to the Vault should be limited. Only some people could go it. Not everyone, only some special people, right? Like your operation colleagues, so they have only access there. It should not be the password for everyone to come, okay? And in theory, yes. What is even worse for me, the Vault does not fix your CI/CD leak, because you need to get the password, right? And once you have it in your CI/CD, the Vault will not fix it. It will only fix it's not in your configuration. And yes, maybe you have one password if you want to connect your application, but it's only one. That's still better than having dozens, okay? Again, nothing from this is bulletproof. It's only layer after layer after layer, okay? This is only how to make it convenient. That's it, okay?
Okay, do we have any questions from the audience? Somebody has a question? Okay, so thank you very much again, and now please go to the lunch.
check.
Jeden, dva.
Nemám chodit moc daleko do publika?
No, bol by som radšej. Ale akože keď si nájdeš nejaké miesto niekde, tak s tým využiť. Len problém je, keď niekto chodí, že tma, svetlo, tma, svetlo.
Jo, jasně. No, tak já zkusím být.
Haló, počujete ma? Takže takto sa Barborka rozpráva do mikrofónu a môže si to natrénovať. Môžeš nám aj niečo povedať?
Aha, OK. Neviem.
Skús ešte niečo povedať.
Dobre. Neviem.
Robíme zácvik nového moderátora, takže... A môžeš to natrénovať teraz, dobre? Dám ti meno. Len povieš jeho meno, dobre?
Koho?
No, speakera.
Tak to povedz.
Tak povieš len, že zdravím pána Radka.
To mám povedať?
No ešte nie teraz, ale o jednej to povieme.
Že zdravím.
Hello there. I'm here to speak about nothing.
Alebo tak, že pár praktických rád. Takto, keď máš ten mikrofón, tak
To mám i takhle?
mu ničíš fyziku a ničíš mu potláčanie okolia. On takto má väčšiu tendenciu väzby.
Hello.
Problém, ale je lepšie ho držať trošku nižšie pod tou hlavou.
Tady?
Ten prst tomu robí zle, čiže keď si ho takto prechytíš, tak je to...
Tady. Hello there.
Tam, kam svietí, tam počúva.
Hello there. Aha. Okay, I'll try doing this. If this sounds okay, if this would be feasible in the... You have cameras here or... Fuck. Recording everything. Okay, I'll try not to swear.
the illustrated Children's Guide to Kubernetes.
Hello, everyone. I hope you had a good lunch and welcome. And I would like to welcome Radek Schmidt with how to explain Kubernetes to absolutely anyone. The stage is yours.
Thank you very much. So, hi, and welcome to my lecture on how to explain Kubernetes to absolutely anyone. So, okay, who am I? I do DevOps at Cloudera, and basically I also studied at Matfis how to teach computer science. My master's thesis was about how to explain what is internet to kids. And today I'd like to talk about a few things that I think are a little bit of a problem in the CNCF world where we all live in, and that's how to explain Kubernetes. So today my lecture will be split into 4 parts. Why should we even do this? Why should we bother? What's the state of the art? And some possible approaches and my proposed solution. It's a draft. We can think about it. But I at least want to set a framework from the perspective of someone who did have some experience working with kids in elementary school or all sorts of ages. So firstly, why should we even do this? There's a big difference we must acknowledge first before we start talking about how to explain Kubernetes, because there are 2 different things. One is what is Kubernetes, and second one is how to explain Kubernetes. So I'm going to talk about the second thing today. I know that all of you are probably Kubernauts, CKAs, certified ninjas here. So my goal here is to bring it a little bit closer to you, how you can talk to other people about Kubernetes, about what we do, because I think it's important. And why do I think it's important? So there's a very, very nice joke here. There's an alien coming to our planet, and it speaks in another language, and it says, Kubernetes is a portable, extensive open source platform for managing containerized workloads and services that facilitates both declarative and configuration. So to make this joke much better, this is actually the first sentence you see when you go to the Kubernetes documentation official start. Let's learn it from the very first beginnings. This is what you get. And we all know Kubernetes is notoriously hard to explain, but why do we need to explain it? And I think the value lies that management needs to understand. Not everybody in your office is so great as you are in understanding all of these abstraction layers. And most importantly, where the money is, right? The customer needs to understand what it is and what do we use it for, right? Because he might want to buy it, or he might not want to buy it, and that advice is very, very valuable. So to lighten up the mood a little bit, maybe you don't understand this, but people actually have problems, and people are actually struggling to understand Kubernetes when they get inside of all of this CNCF mumbo-jumbo. There's even a lot of memes. I really like the one where the guy hangs himself before he gets on the complexity curve, you know? But those are just jokes, right? This is no rigorous research. So if you Google Kubernetes, if you literally Google the sentence, what is Kubernetes, what you're going to see is everybody from the public clouds also sees this problem, and they also are trying to understand it. So here's GCP, AWS, and Azure. They all have a big page with a big line that says, what is Kubernetes? And it's not just them. It's also Red Hat, IBM, Oracle. Everybody sees that people don't understand this, and that we should that we should try to explain it to them. So, bringing it back to the original text I quoted, Kubernetes is a portable, extensible, open source platform, something. It's very easy to say complex words. And I want to say this because I think a lot of people in IT, a lot of my colleagues, me too, are suffering with this thing that they explain things with very, very fancy words. And I don't think this is particularly useful other than like flexing who knows more of these fancy words. I really think it's actually quite easy to say a lot of very complex, very fancy words to explain complex concepts. The go-to example I always use is, so if a child, if like a 5-year-old child asks you a question, why do things fall? Then you answer, it's gravity. But you just use the fancy word for like, things are falling down, right? The child asks a question, why does it happen? And the approach that we solve it by making a really fancy word for it and using that word between each other or with other external people, this doesn't make things easier. So it's hard. It's really hard to understand Kubernetes, and it's even harder to explain it. That's why not many people do it, and that's why we have all of these fancy words that we use. So let's think about this like engineers, right? So what's the state of the art? As with any other problem, we first examine what are the solutions available to us. So basically, we have the platform for building platforms. You probably heard this thing from Kelsey Hightower, a bunch of KubeCons back, right? Which doesn't really help us when we don't know what Kubernetes is. We know it's a platform for building platforms, great, but what is it? What is it, right? Then we have the documentation, I quoted that. Then we have some blog posts from Big Tech, I also showed that. Then we have Udemy and YouTube. There's a lot of great resources, but they're all also very technical. I really liked the one from Mamshad Manambet. There's also Tech World with Nana. And there's also these IBM videos, but they're all very technical. Like you can even see in the video with the right down corner how he's writing all of this technical stuff. Then you have Reddit, where you can ask stuff, and then you have Phippy. Phippy, I guess you're familiar with it. It's an animated children's guide to Kubernetes. So anybody knows about anything else that I missed? Maybe I didn't do my research properly? Or are we in agreement that this is kind of like where the state of the art is? All right, I don't see any hands. Thank you very much. So I did my homework well. So Reddit, the best answer I could find is about 4 years old, which says Kubernetes is like a guy who takes your container, and if he's sick, he takes him out to the barn and shoots him and buys a new one. So I think this is a fairly good explanation of what Kubernetes does, right? But maybe if some of you in the audience don't know what a container is and can't really imagine how Kubernetes can like kill this container, then it might be a little too abstract. But sure, why not? I like this. This is a good explanation of what it does. Then we have a lot of these diagrams. Those are the favorite diagrams that are on the original documentation and stuff. And then we, of course, have Phippy. Phippy is a children's fairy tale trying to explain Kubernetes to you. Phippy is great. I love him. So let me just
The Illustrated Children's Guide to Kubernetes. Once upon a time, there was an app named Phippy, and she was a simple app. She was written in PHP and had just one page. She lived on a hosting provider, and she shared her environment with scary other apps that she didn't know and didn't care to associate with. She wished she had her own environment, just her and a web server she could call home. An app has an environment that...
So you might see what the problem is I'm trying to explain here. So in the 30 seconds, at the start of this fairy tale, they use fancy words like web server, or environment for the app, or like PHP, you know? Not everybody knows this. This is not something that comes natural to people. So although I love PP, I think it's great. I think it tries to achieve a little bit too much, explaining what Kubernetes is. So the first thing, so let's talk about possible approaches here. So the first thing is, it's not for me. My brain cannot understand it. So this is a very, very common first thing you will encounter. You will talk to someone, and you will tell them, and maybe you can also learn Kubernetes, and they're like, no, my brain is unable to do it. And my response to this would be, so like think 200 years back, you're at this aristocratic table, and you're like debating your aristocratic friends. How much of population can learn to write? You know, like letters. This is a very complex thing, much more complex than Kubernetes. And maybe you'll agree that maybe like 20% of these peasants can learn to write, maybe 10%, maybe 50%. But the reality is, everyone can learn to write. We know it. We know this. So everybody can understand the abstraction behind Kubernetes. It's not that hard as writing, you know? The second thing I want to talk about when we discuss possible approaches. First, explaining what is Kubernetes is very different from explaining how Kubernetes works. We often drift inside of this very comfortable space where when people ask us, what is Kubernetes? We tell them, so there's this API server, and there's this scheduler, and they both run as static pods created by the kubelet, right? You get what I'm saying. They don't get what you're saying. So explaining what is Kubernetes is sometimes much, much more important than explaining how Kubernetes works. Where is the value in that, right? So to drive that point home, if you Google what is Kubernetes, the first thing you'll see is what is Kubernetes, and then you'll see what is Kubernetes used for, and then what you will see, it's like a story. What Kubernetes is used for in simple words. People go on this way, and they don't find it. They don't find it, what it's used for, because we don't tell them. So there's a bunch of stuff what we can do, right? We can tell them, so here you can see how these things are different, and we can sometimes use metaphors to do it, right? So there's a story I asked one of my friends in the company who's and she's non-technical, and asked her, what is Kubernetes? And she's like, oh, I heard this very good explanation. It's about a kitchen. It had something with a kitchen in it. I remember it. Yeah, but you don't know what is Kubernetes, right? So there's a bunch of metaphors, I linked to them here, which show you how Kubernetes works inside on the metaphor of a kitchen, but this doesn't help people when they want to know what is Kubernetes. And the best part are these AI-generated pictures, which are sometimes wrong, and they don't make any sense, and they don't help anyone. I love it. So easy to create this slop. So, no, I'm sorry. I don't want to be rude to anybody who created this. So, we also need to explain it to them simply, but we must not lie. We cannot tell them that Kubernetes is something that it isn't. So, what can we do? We can talk about the utility of the product. So, let's say you want to explain what Kubernetes is used for, what's the utility of it, to your grandmother. You can use something like factories needed to operate, for monitoring, for making glasses or something like that. You can say that we make sure that the websites are always running, which is something tangible and something that has value inside. For other engineers, we could say it's a useful abstraction on top of hardware. Engineers don't want to touch hardware. They just want to write code for it. So we use this abstraction. Good. Utility, right? We see the value behind it. For non-technical people, you can do similar things. One of my go-to things is to say Kubernetes is a system of automatic administrators. So administrators, usually they fix your app when something is wrong. So Kubernetes is an automatic administrator. It fixes apps automatically. And for a child, maybe you could say it's a way to connect 1,000 computers into one big supercomputer with so much power. So, but for the business people, what do we say? So maybe we can say it's a way to connect 1,000 computers into one big supercomputer that has all the power inside. And maybe we can give it our corporate credit card and it can rent out more computers if it needs to. And that way we can save money when we sell them back. This is a good way to explain them why Kubernetes is useful and where the value lies. But it also doesn't answer what is it inside? How does it, what is it actually, right? So then we can say Kubernetes is a fix for very important questions. So there's a lot of very important problems in IT, and we keep solving them again and again and again. And Kubernetes is really good at solving these big problems, like how do you get 999 availability? How do you deploy a new version safely? Kubernetes is an answer to this, and we can do this. How do you allow the app developer to choose the storage system, and they just get it, right? This is a very important question that that we have in IT, and Kubernetes is the answer to it. So that's one way to do it. And the last way I want to talk about is a similar abstraction to operating system, right? So Kubernetes is sometimes called operating system for the cloud. Again, fancy words. We're not sure what it means. But when you spell it out, it's actually like very, very one-to-one, right? So it's a one system that has multiple components running, and we just package it together and say, like, this is the system, right? We don't talk about, like, systemd or bash being too separated from, like, Linux. We, just as we can say, like, it's Kubernetes, and we don't need to think too much about, like, the type of scheduler we use and stuff. You can start apps on it, right? It doesn't matter that there's a sandboxing abstraction called containers, or there's a sandboxing abstraction called something else, right? We can run apps on it. The apps have to be written in some way, but we can do it. So you can read the rest of the stuff. The only difference is that it runs on much, much more computers. So what is my proposed solution? If I were to explain what Kubernetes is right now to someone, I would like to propose you guys a draft solution for this problem. I'm going to say something that is very, very simple, right? You need to start easy and then move to hard, start specific and then move to abstract. And this seems like of course it's like this, right? It's even a naive way, you know? Of course it's like this, but nobody does it. So, let's start with a cup of tea. Let's start with a cup. Please, Luboš, don't write me on Slack. Let's start with a cup of tea. So, if you want to have a cup of tea, you need three things. You need water, electricity, and tea. So in order to get into your house the water, there are thousands of people that maintain the infrastructure, the systems of pipes, the reservoirs. All of it is necessary to get you the water inside of your tap. Same thing with electricity. Power plants need to work. Thousands of people every day take care of this problem. Same thing is with the roads on which the tea is driven to the supermarket. Thousands and thousands of people need to work every day to make this one cup of tea happen. So this is starting simple, starting from specific. So now we move to hard. Let's say you want to watch a YouTube video. You need the electricity. We already talked about this, right? But you also need internet. If you need internet, there are thousands of people, divers, who service the underwater cables. People who put the underground cables there and service them if something happens. People who maintain the crossroads. People who maintain the data center, right? Also something very specific. And you need YouTube to be working, right? You understand the problem that internet can be working, but YouTube can be down. So we can move from the specific thing into like abstracting it, right? So YouTube needs to be working. So that means YouTube's running somewhere. YouTube is an app. And YouTube as an app has two parts, right? The one on your phone, and then the one inside of the data center. That's where the big computers are. That's where it's running, right? So YouTube as an app has two parts. One somewhere on your computer, then there's the underwater cables, and then it's running somewhere else. It's an app running on somewhere else. In a big warehouse filled with computers. So, YouTube is big. YouTube cannot fit on one computer. Everybody can understand that, right? YouTube has millions of videos. YouTube definitely doesn't fit on one computer. So, there's a warehouse filled with the computers, there's data center. People need to care about it. And Kubernetes is a big app that's running on all of these computers and allows us to use them together. Kubernetes is the automatic administrator of many computers at the same time. So, here we have the data center, and instead of putting the YouTube app, second part, on the computer, the small computer over there, we put it here, inside of Kubernetes, because Kubernetes is running on multiple computers at the same time. And then someone can ask, and we answer with the app. Of course, this means the app needs to be written in a very specific way, but that's okay. People understand this. So, Kubernetes, now we can move to abstract and hard things, right? So it's a very clever system that can also do a little bit of 24/7 support for us. So if your app dies, it will restart it for you. So it makes sure the YouTube keeps running. Maybe someone experienced the CrowdStrike problems that happened because of one update going badly. We can say Kubernetes is helping to prevent this. Kubernetes can do like a canary and test it out on a very, very tiny amount of people if the update is breaking anything. And then if it isn't breaking anything, we can roll it out to more and more and more people. And we can move from data center to data center much more easily than we could before. Or at least that's the promise. So, getting back to our diagram here. Let's say our YouTube gets more people are using it. It needs to be bigger, the app. There's thousands of hours of video uploaded to YouTube. We need to make it bigger. So we're kind of afraid that YouTube's going to be too big for our Kubernetes. So we give Kubernetes our credit card. Everybody knows what a credit card is. We give it our credit card. And then Kubernetes can decide, oh, I will rent 2 more computers, and I will add them to me, and it will start growing. So that's how I think about Kubernetes. That's my draft proposal of how we can approach this problem from very, very simple steps, incremental steps to help other people understand what is it? But as with anything, you need to keep in mind they must want to learn it first. If you just start explaining it to them, it's not going to be any good. So thank you very much for your time. If you want any Q&A, we can do it. An app, that's the thing on your phone that you can tap it, and it's gonna do stuff, cool stuff, right? Yeah, yeah, all of it's an app. Thank you. Okay. Anybody else?
There is a question.
Yes?
You should try to write some Kubernetes essay as a remake of the famous iPencil story.
I don't know iPencil story. Can you elaborate? Okay, I'll Google it. Thank you. I'll Google what is iPencil story. Ah, how pencil is made. Okay, okay. Thank you very much.
Another question. Have you considered how to explain Kubernetes to detractors like some Linux admins?
So I think I kind of touched on this during the presentation with comparing it to an operating system. So if somebody is an experienced Linux admin, I think that the first thing you can tell them about Kubernetes, it's like an operating system running on top of it, and it tries to do your job. Sometimes very well, sometimes not.
I am really glad that we had this topic because I brought here my daughter, and it's maybe 6-7 years that I am trying to explain what I am working, and I'm not still sure she get it. Can you now tell us what you take from this?
Yes, I think I understand it now.
Explain. Nice. So when?
Okay.
So please, when will you start contributing your first code to Kubernetes? That's more important. No. Thank you very much.
There's one more question. How can Kubernetes make your app alive when it dies?
It restarts it? No? It restarts pods. If there's like a, let's say, segmentation fault in your Go code, the Go code dies and it restarts the pod. I'm not trying to complicate this, guys.
Okay, any more questions from the audience?
Okay, thank you.
Hello everyone. Now we are going to another presentation. Now we have here Štefan Roman, and he will be talking about fast storage, hard lesson, a war story of stateful Kubernetes. The stage is yours.
Hello guys. So my name is Štefan and I work at Labyrinth Labs as a DevOps engineer. I'm here to share our experience with deploying a really high-performance database in Kubernetes. Some of the stories are a little crazy, but let's go through them. So hopefully, if you're going through the same thing, I can give you some pointers on what to look for. So just to introduce my company, at Labyrinth Labs, we help companies migrate their existing workloads or new workloads to AWS EKS a platform called Lara. It's our own infrastructure, plus some data operations that are involved in running such a platform. Lara minimizes downtimes, technical debts, operational overload, all that good stuff. So we are very proud of it. So why am I here? So one of our customers has asked us for deployment of ScyllaDB. It's a really high performance, single-digit millisecond, single microsecond performance database. We decided to place it onto AWS EKS, onto instance stored disks. For those who don't know, instance stored disks are ephemeral. So they're very blazingly fast. The location to them, to your actual hardware is very close, so it's kind of a benefit. But if you reboot your instance, you lose your data. So it's kind of, for a database, it's kind of a icky situation, but we actually managed to make it work. Like I said, the requirement was single-digit millisecond latency or microsecond latency, and that's under a huge load. I mean, that's tens of thousands of operations a second, write and read, maybe even hundreds of thousands. We decided to put it on Kubernetes because we just wanted a unified API. I mean, isn't it great if your application lives by your database? I mean, that's pretty cool to actually see it as a pod, you know, in your Kubernetes cluster. So, you know, we thought if we can actually rebuild the data, you know, and do it in like quite a good time. If your node goes down, then I mean, who cares? You know, we can actually do it. But there are nuances, and I'm gonna kind of speak about the journey of what we looked at and what I'll be speaking about. I'll be speaking about some kernel and some OS config. Don't worry, it's not going to be a lot. Some EC2 instance decisions. Like I said, we used instance stored disks, and I know that's kind of a polarizing topic, especially when it comes to stateful databases and workloads in Kubernetes, but I hope you'll understand at the end. I'll be speaking about some Kubernetes configuration and scheduling and things like that, and also some data operations. We did a huge amount of testing and you know, upgrading, backups, things like that that are actually required for a data operation. And also at the end, I'll be speaking about Kubernetes DB operator, because of course this database, this Scylla database, was managed by an operator. And after this task, I think we get a pretty good idea of what an operator like this should actually handle and how it manages the database itself. So some low-level stuff. I picked, you know, one very important one and one very interesting one. There are literally dozens of parameters that need to be actually looked at on the underlying operating system and kernel to be able to get the most out of your database. And that goes to Kubernetes, and if you just run it on wherever. So the couple very important ones is SHM max and all, and that pretty much defines the how much cache you have on your system. I think there is like a default value that comes with every single Linux system, and these two parameters actually can adjust the amount of cache memory that your database can use on your system. So I guess it wouldn't make sense. You have 4 gigabytes of caches, and then you have 256 gig instance. You know. if your database is, I don't know, you hit your database with the read query, it wants to cache that query into memory, so that if another read comes in, then it just gets the response from cache instead of hitting the disk. So, you know, if you don't have the caches configured properly, then you are hurting your performance. So that's very important. And a very interesting one is the clock source, which I had no idea before actually doing this task. And if using the TSC, so clock source equals TSC, it lets the read time, it lets the system read the time directly from the CPU instead of going through the hypervisor, then kernel, and then CPU. It's microseconds, but it actually matters when you are hitting your database, you know, hundreds of thousands of times a second. You know, these things can add up. So this usually is set to something like clock source equals KVM something. So this is important. So another low-level stuff that we actually had to take a look at was CPU pinning. This literally reserves entire cores for your single process or multiple processes that you want. You can do it in actual Linux. You can do it in Kubernetes. And this is not to be confused with, you know, setting your requests and limits on your pod, you know, because this is actually reserving your entire core just for that process, and no other processes can be scheduled onto that core. So even if it's bored, you know, no process is allowed there. And that's very beneficial for some databases, because if you, for instance, Linux system has some kind of a priority on what it should process first, and one of the big sort of priorities have network packets. So imagine you have a network attached database and a network packet comes in, or let's just say that you hit your database with a read, it's in the middle of being processed, and then another network packet comes in, then you interrupt that process, you process the packet, and you continue processing your query again. So it kind of degrades the performance, and CPU pinning is actually extremely beneficial for some databases, and it's beneficial for databases which have their own CPU scheduler. So something like, of course, Scylla, Cassandra, even Redis, I believe ClickHouse, and databases like, for instance, Postgres or MySQL, they use Linux scheduler, so it's kind of, they don't benefit from it as much, but yeah. And of course, this approach is not very beneficial for every single situation, because you literally reserve an entire core for a single process. I mean, you know, if it's bored, you know, it's there, it's unused. So, but for databases, for Scylla, that was perfect. Oh, I forgot. So you set it up by kubelet. Config is just literally one single parameter. It's just CPU static policy, CPU policy equals static, and then you make sure that you have a quality of service class of guaranteed for your pod. So that pretty much means CPU request and limit has to equal, and then memory request and limit has to equal, and then you have this class. So going back to this Scylla DB. Scylla DB used like a privileged daemon set. It was scheduled on nodes where the Scylla pod was running. It was a big Python script that actually fetched everything from the system and then configured every single parameter as best as it could to actually house Scylla DB. So that was relatively easy. But one of the caveats is that in our platform, the default operating system that we use is BottleRocket, and it's kind of a little bit security-orientated system, and it doesn't actually like some of the kernel parameters, and it was just erroring out, crash looping, and stuff like that. So yeah, we had to switch the operating system to Amazon Linux 2023. Or maybe Amazon Linux 2. I can't remember exactly what, but it provided us with a little bit more lenient security parameters. So storage, very polarizing topic. So let's just say that Amazon has like 2 categories of storages. I'm not going to mention EFS because it's completely irrelevant. But for EBS type disks, they have 2. It's GP3 and IO2 with respect to their previous versions. But the GP3 we looked at and it was just too slow. It's a general purpose disk. We didn't actually care about it because the latency was preposterous. But we looked at IO2. And it was actually very interesting because the maximum amount of IOPS was 256K. That's a huge amount, but the problem with this disk was that it's still kind of within the vicinity of the instance. AWS guarantees that it's kind of close, but they also guarantee of average latency of 500 microseconds. And if you are dealing with single-digit millisecond latencies, this is a lot. And that's average. That can be from anywhere from 10 microseconds all the way to 3 milliseconds or something like that. That's impossible to actually manage in that kind of circumstance. So instance store it is. Definitely the performance was there. The actual residency, so the location of the disk was right next to the instance where your virtual machine is provisioned. So it's right in this metal box. So it's NVMe drive. It's blazingly fast. There are caveats though. It's not as fast for every single instance size. So if you are increasing the instance, you're increasing the space and the speed also. And it's local storage, so if you reboot your instance, you lose all data. And it's kind of icky for databases to lose data like that. But we thought, hey, if we can, rebuild this data every time a node goes down, who cares? And also there is a time component to it, but I'm going to talk about it a little bit more later. So also one of the issues why we didn't pick the IO2 volumes, and you don't have to shout, but you just internally just guess the price of like just the basic IO2 equivalent volume to instance store that we were kind of handling. So IO2 volume 1 terabyte and 100,000 IOPS provisioned. So just think for a second, and that's the price, and that's for 1 disk. Okay, so imagine you are running 3. We were planning to run 3, but imagine if you're running more databases like 6, 9, 12, instances, and I mean, your instance costs 800 euro, and all of a sudden your disk costs I don't know 8 times that. So not possible. So instance store it was. Also, the disk speed was very, very important because some databases, and Stila included, they have some database pre-flight checks. So I don't know, think about it like a smart benchmark test that's right at the beginning of the startup time of the database, and it's got some kind of a benchmark, and if it doesn't hit that benchmark, it just crash loops. So it's very, very important. So that's for storage. We got instance stores, and now for scaling and scheduling. So we had to play around with HA. So we decided to provision the database pods, each on their separate node, and of course each of that node has to be in its own AZ for every single database replica. We had 3, AWS has 3 availability zones, so it kind of worked out great. If you're running 6, 9, you just put 3 or 2 in each zone, but it has to be spread for the true HA. And don't forget about the database operator too, if you're doing it on your own, because you just are in the middle of a rollout and all of a sudden, I don't know, Carpenter or Cluster Autoscaler or AWS decides to kill this instance, and you're gonna end up with a broken cluster. So HA for that too, and the HA we achieved with pod anti-affinity and topology spread constraint. It's kind of basic Kubernetes concepts, and also we wanted to make sure that none of the other workloads that we were running on the Kubernetes cluster, because it's a shared environment, are actually interfering with our Stila database. Of course, it's a separate node group, and you really want to have any single like really specialized workload somewhere else, because one, noisy neighbors, you don't want to have some kind of Josh's batch script to actually messing up your database and your database performance, or kind of like, I don't know, some kind of upgrade policies and stuff like that. It might not actually work for that particular node group or workload, so you just put that somewhere else to actually live elsewhere. But you need a scaler for that. And the first thing that we looked at was Carpenter, which is a default in our platform. But we looked at some of the parameters that we actually had to configure, and one of those was consolidation policy for Carpenter. The consolidation policy that we had default at the time was when empty or underutilized. And the underutilized is very, very important, because your Carpenter can decide to kill your database if it's actually bored. So you really don't want to run this consolidation policy. You know, over the weekend, if your database is bored and it's got a CPU of 8%, then Carpenter goes, oh, look at this. You know, I can just kill it. So yeah, not very good, especially if you're running those instance stores. So you can lose your whole cluster based on that. So, of course, the consolidation policy was changed to when empty. It's much, much safer. Also, there is a do not disrupt annotation that Carpenter respects on your workloads. So it pretty much means do not evict, do not do nothing to this workload. It just wants to live. Don't touch it. And that's the bare minimum. Carpenter has a crazy amount of different time settings and whatnot that you can adjust. But this is definitely bare minimum. Unfortunately, we couldn't use Carpenter, even though it was the default, because at the time, our platform didn't support the Amazon Linux operating system. It just supported BottleRocket. So we had to go with Cluster Autoscaler. It's got a kind of a similar kind of annotation. It's called Safe to Evict. It pretty much says, do not touch this workload, no matter what. It provisions EKS managed node groups in the background. They are backed by autoscaling groups. I'm gonna go into that because we found a pretty devastating issue with that. Also, I set minimum instance amount for every single one of your groups because you don't want to trust your scaler to just keep it at 3 or 6 or 9. You just always have to have that minimal because you might actually turn up to work and see your database scale to 0. So you don't want to do that. Okay, so what do we have so far? We have kernel, we have storage, we have high availability, we have scaling, we have operating system, and now we need testing. So we've done a lot of testing. So you eat what you cook for yourself. So we need to test it as much as possible. So first, a very basic test, we terminated a node underneath a running cluster. So we just logged into the AWS console and terminate the node and see how the operator kind of manages that operation, how long the data is being rebuilt, and kind of what happens if it's going to actually recover from a loss of data like that. So the operator actually has to manage that life cycle. And that's how it kind of looks from the perspective of the operator. So like a node is lost, then a new database replica is provisioned and created. Then the scaler looks at the pending replica, says, oh, I need to provision new node. So a new node is provisioned. The replica is scheduled. And then the operator realizes, oh, I have the new replica. So it joins it into the database cluster with some magic commands and whatever the internal mechanisms are. And then the new replica actually starts receiving the data. And the operator should also make sure that the replica does not get any new traffic, so I don't know, the data doesn't get corrupted or anything like that. So once it's ready, once it's fully migrated, then receive traffic. So the next thing was instance upgrades. We want to be able to upgrade instances because businesses are changing, businesses lose customers, businesses gain customers. The instance store disk is kind of static, so it scales based on the instance size, and the speed also scales on the instance size. So we want to be able to actually upgrade the instances and not be kind of like really static. So we tested that. And we found an extremely devastating issue because, so what we did, we replaced, bless you, and we replaced the EKS managed node group. So we're running node groups because it's backed by cluster autoscaler. And then small clusters, extremely fine. Everything was replicated in time. Everything was great. But larger clusters, we put like a lot of testing data. It was around 300 gigabytes, and there was a huge problem. So let's just talk about what we did and how we did the actual process of it. So the new node group was created, and old one was deleted. Then operator terminates 1 DB replica, then new DB replica is created, pod disruption budget kind of holds everything together, and then we just wait for the data replication and then repeat for every single one of the nodes. The pod disruption budget was set to a max unavailable equals 1, so only 1 replica can be down at a time. So perfect. I think that's a good plan, right? No. The instances in the old EKS managed node group were force killed, disrespecting the pod disruption budget after 15 minutes. And that is a feature. So we found that later in the documentation. Yeah, that is an actual feature of the autoscaling groups and the whole processes, just to kind of free up the resources. And for databases like that, that's the end. So what do you think happened with the cluster? You lose all data, every single one of them, because the replica that was just being scheduled onto your new node, it's in the middle or in a quarter of the data replication, and your 2 or maybe even more old pods were just force killed. So the replication didn't actually finish, and your instance stores are gone. So it's rest in peace dev cluster. We actually found later on in the documentation that is a thing, but we learned something, and that we actually relied on AWS, and we assumed that that's what's the case. It just kind of has to automatically respect pod disruption budgets, right? It can't be anything else, but it wasn't. So we upgraded the process, and we did the following. So we created a new upgraded node group in parallel. So there is an old node group and new. And then we cordon every single one of the old nodes. So just so that there is, once we start migrating the pods over, there is actually no chance that some kind of a scheduler would schedule the same database pod onto the same old node, so that we have a guaranteed of being moved to the new node group. And we scale down the node group, the old node group, one by one. So we kill one node, and then one pod gets moved over. We kill another, one pod gets moved over, and we have complete control over the actual process. And you can wait literally weeks for the data replication. If you have 500 million terabytes, you can just wait, because you have complete control. You don't rely on anything else. And after that, you just remove the old node group once it's empty. So that worked very, very well. Another thing was operating system upgrades. You want to be able to do that also, because of course CVEs, random deprecations and things like that, security problems. So you want to be able to actually have some kind of a system to deploy a new operating system. And they were a little bit simpler, because the EKS managed node groups could be upgraded in place, so you don't have to do the whole shebang with creating a new one and migrate them over. But the data still needs to be rebuilt. And we thought about the future, saying, hey, if this cluster goes to like 1 terabyte of data, which we didn't actually have tested, what if the autoscaling group just kills the old node, and we couldn't actually rely on it. We were so paranoid from the previous experience, so we just ended up using the same process for the instance upgrades. So it was bulletproof. We had everything under control. We could take weeks in migrating data. We could take weekends off, when we were migrating the data over. So it was great. But during this OS upgrades, we found a bug in the Stila DB operator specifically, and that the replica, for whatever reason, race condition, something like that, was unable to join the cluster. So it was just scheduled, and then all of a sudden crash loops and crash loops and crash loops. And the operator was like, I don't know what to do with that, and it was just spewing out errors and stuff like that. So actually we had to go to the source code, to GitHub, and actually analyze every single aspect of the operator and what exactly it does, what it adds to the pods, what it takes from the pods, what commands it executes to be able to actually join one pod into the cluster. And we reverse engineered it completely, and we found that there was an annotation missing that was supposed to be added onto this new pod. So we added that annotation, and then we seen the operator jump to like a next step and spews out some other errors. And we were like, oh my God. So, okay, so we actually went into the database and we accessed the system tables, and we deleted the old node and actually put the IP of the new node, and all of a sudden data replication started. So yeah, very, very scary stuff when you're in production, but this was in testing. So when it comes to database upgrades, you want to be able to go through breaking changes and upgrading Stila database. At least Stila database was handled by the operators. So you had a CRD with like a Stila version parameter. You just put 6 instead of 5. You deploy it, and Stila does the rest. It's easy peasy. We also tested for very big disasters. And then, for instance, if you have a availability zone failure during a rolling upgrade. So we want to be able to see how the operator handles that kind of a thing. So if you can rebuild the data with 1 replica out of 3. And turns out it depends. And it depends because each database engine is different. And it actually depends on that database engine. Stila, for instance, could actually, I swear to God, this is not an ad for Stila, but at least Stila DB was able to recover because it has a particular setting. It's called the replication factor. You set it to an integer value. And that basically means how many replicas of the entire cluster data is on your cluster. So we had a cluster of 3. We set the replication factor to 3. So every single one of the nodes has a whole shebang of data. I know it's storage intensive, but you can actually survive failures like that. So what are some of the takeaways? If you want to do it yourself, if operator that you find doesn't have basic functionality, adding nodes, removing nodes from your cluster, if it doesn't have backups, restores, forget about it. Don't bother. Don't do it. If it's installed on your cluster just to look pretty, don't do it. Operators, in our humble opinion, operators should have mechanisms to adjust the kernel, same as Stila. There is a script that does everything for you. Or at least, if it doesn't have that, it should have grade docs, some additional scripts in the repository to configure certain parameters. But the grade documentation is actually essential. Also, be careful if you pick some kind of an operator and you are running Talos or Bottle Rocket. They're configured a little bit differently through an API, especially Talos. Bottle Rocket had the security problems, so you need to pay attention to that also. Also, upgrading your operator. That's different from upgrading your database. Of course, it's a Kubernetes, so there are CRDs, there is alpha versions, there is beta versions, there is breaking changes in between. And does your operator actually handle the breaking changes like that? If you are migrating from a database to a database, it's got to have to do that. Also, read your operator guidelines. What happened to us with the Stila DB bug, we don't know, we have no idea, right? So read your operator guidelines, and if your operator does not support all operations that you can think of, ask yourself or find out in the documentation if you can do it somehow manually. Because if we couldn't actually put the instance or the new pod inside the system tables of Stila, we would lose the cluster in production. So that was, you need to be able to do things manually. Of course, the operator should handle any breaking changes. So Postgres operator, one of the Postgres operators has PG upgrade CRD, and you just put from version to version, and voila, everything happens kind of magically. I haven't tried it, also take it with a pinch of salt. We just tried Stila. Also, some of the soft skills, or I guess soft stuff that you need to be paying attention to, is the operator created by the database developers, or is it some kind of a university project? I mean, no disrespect to universities, but you know, if it's just 5 students actually putting their heads together and creating something great, and then they find a job somewhere, and then they abandon the project, going left with a deprecated operator and your entire core business on a deprecated piece of software. So, you know, you need to be paying attention to that also. Also, read GitHub issues, see whether the contributors actually respond, fixing issues, are there frequent upgrades, releases. If the last upgrade or release was 2 years ago, you know, don't use it. For instance, for Stila, it was 4 years old at the time, and it still had issues like that. You know, it still wasn't able to join this node into the cluster for whatever reason. So, and that's pretty important. And the biggest takeaway is testing. You know, we spend more than 85% of the time just testing. So be like GLaDOS and test. And also we have an open position for platform engineer. So if you are interested, there is Zuzi, my colleague. She's great. Speak to her if you are interested. So thank you very much. And now.
Okay, thank you for your presentation. We have one question in Slido, and if is another question here in the room, you can raise your hand and I will give you a mic. So now I will read the question. Have you tested behavior during chaos tests, network latencies, network disruptions, sudden I/O spikes, or on particular nodes?
Yes, we did that. Yeah, I mean, the whole shebang. If I had more than 1 hour, then I could be speaking about the whole shebang of tests. But when it came to network interrupts, things like that, it just degraded the performance. You know, if you have an I/O spike, you just putting down the performance, and you just see it in Grafana, in performance charts, that the response millisecond or the latency actually goes up. So it really actually, bigger picture, I think it really depends on your database engine, whether it's able to actually handle that, whether it's going to be a failed query or if it's going to be a return query after just more time. So I think it depends.
Another questions. Do you do backups outside the Kubernetes? How backup restore looks like?
Yeah, perfect. So for Stila, it's got a backup. You know, it's like a cron, and we put that onto S3. So it's outside of the Kubernetes.
Another question, I think the last one. Do you use operator in production, and what is the max volume of the data in the cluster?
So yes, we do, and the max data volume is the 1 terabyte. The database is really high performance, but it's not really large. It's just got a lot of IOPS that's been hit by. So.
Okay, thank you very much for the presentations and for the questions. Thank you. I think that now we have a bigger break, maybe 15 minutes. You can go for a coffee.
Funguje?
Môžem?
Okay, now after the coffee, we will start with our next speaker. It's Attila Mészáros, and he will be talking about Kubernetes Operators Demystified, the building blocks that matter.
Hi guys, welcome to my talk. I'm Attila. I want to basically prepare the presentation for you about Kubernetes operators and controllers, what are the main building blocks and the patterns, and what are the issues, and want to dig deep in some of the topics because I see there is kind of a missing from the air. That's how some of the components are working. Just a few slides about me. I'm co-founder and maintainer of Java Operator SDK. It's a framework for writing Kubernetes operators in Java. I'm a member of a steering committee of Operator Framework, which also manages Operator SDK for Go. I'm a software engineer at Apple, working on a big data platform inside Apple where we maintain open source-wide these two co-operators for Apache Flink and Apache Kafka. And yeah, otherwise building also the platform and everything around it. So just before we start, few quick questions. How many of you deployed an operator on a Kubernetes cluster? Almost half. How many of you started or contributed to a controller or an operator? Few, okay. And how many of you do know what is an informer in word of? Okay, a few hands. I think I don't have to explain this one too much in details. Kubernetes operators are basically an extension pattern to Kubernetes where you have these custom resource definitions that you apply on the cluster, introducing your new custom type to the API. And then you have the controllers which are checking these resources and basically manage some additional resources for you, your application logic, and tries to get the cluster or the desired world, the desired state you describe with your custom resource, well, in the spec part, and there is a status part, which is basically just the last observed state. This lives or exists from the beginning of Kubernetes. Basically, it's always was aware of this and was designed for this intention. Just refreshing some interesting properties. So Kubernetes resources, almost all of them has this metadata resource version, which changes every time if a resource is updated, no matter what or how. And basically, almost until last year, approximately, Kubernetes guidelines has said that we should never threaten these resource version as integers, although it was integers in the background. We should always just check them for equality. This changed recently, and at the end of the talk, this will have also very interesting implications. And then usually in the controller world, but also in general, I think it's what we see is that the API is basically bounding us. So we can do what Kubernetes API provides us, and we can work with that. So there is this first component I want to look about, Kubernetes watches, which is basically says that give me these resources, it will open you a WebSocket and notify me about the updates of these resources. So just don't want to be too abstract, so I will show you some code during the presentation. And you might already know this to some extent. So if I have a cluster, I add there these two config maps in my namespace with some labels, so I don't interfere with some other config maps. I just copy this part. It created these two config maps, and I can just watch these resources using this kubectl watch command. And as you can see, it basically shows you these two config maps with the labels. And if I do a patch, one of these config maps, that here it will instantly send me the updated data with this updated flag. So basically maintains this connection, maintains this WebSocket, and the WebSocket is sending us the updated resources. So this is it, what will be very interesting for us. It works in a way that Kubernetes API caches some recent updates, but only just a limited number of these updates. So then we arrive to our first component, basically the elephant in the room. It's called informers in Kubernetes. And it's a component that's not really part of the controller frameworks. It's part of the Kubernetes clients, both in Java and in Go, and also other languages. And what this does is, when you start an informer, on the beginning it will list all the resources from the cluster. So for example, all config maps. And after it listed, stores it in the local cache, in-memory cache, and then starts watching for subsequent new updates. And also has a callback method, so you can register a callback and will notify you about some additions, updates on these resources, and deletes. So it's very handy because you always get notified, and on the other hand, if you want to use that resource from other parts of your application and not necessarily a controller, any application, we use those for different purposes, typically in special applications. And basically, you always have the in-memory cache and last kind of eventual last state at your hand. So how it looks like in practice, in Java, it's just a very simple code. Basically, we initialize the Kubernetes client, and I tell him that inform me about the config maps, and just notify me on these callbacks when that happens. So if I run this, I'm not filtering here on label selectors, but as you can see, basically lists me all the config maps on the cluster, including the two I created recently. Hope it's visible. So basically that's it. And then we have this API which says that give me from the informer the cached resource with this namespace and name. So you can also see in these logs. That's a relatively handy tool, and I want to go a little more deeper in that. How does it work in the background? So yes, it lists the resources, but it lists with pagination. So if you would have a large cluster with thousands of custom config maps, listing all at once would kind of create too much pressure on the API server, so memory issue could arise. So there is a pagination. And from that, it actually creates a watch which has a timeout. So purposefully breaks the connection on every 5 to 10 minutes. It's randomized in Kubernetes. And also there is this resource version that sets you from which version to send me the new events, and some other improvements with bookmarks that we might touch. So if we take a look a little bit more deeper at what it actually means, in my fancy README document, if I execute this row list request, it returns me these two config maps. And nothing special here, it's a JSON representation of the config, except this thing here. It's a resource version on the list, not on the config maps. And it's not a resource version, any of these config maps. Basically, it's a global maximum on the Kubernetes cluster. And we are actually using this subsequently for the watches to watch for subsequent resources using, we'll copy paste this. and put it here on this watch. Oh no. And as you would expect, it doesn't return nothing because we didn't change the config map. What is interesting on this, if I put here some low value, so not what the actual one we received from the cluster, just a very low level, we receive an error. It's called too old resource version. This would mean that we are out of the bounds of the Kubernetes API server caches. So the watch cache doesn't contain this resource with this version. So this, in practice, can mean a lot of things. Basically, we are breaking these connections, so it might happen that we are just going to sometimes initiate again the watches. In some extreme cases, we want to even relist at some point of time. So the point of that is that this notification, what we get in the resource event handler, and why we are getting these resource in caches, in some cases, it will just lag. It will have a bigger cluster, so a higher delay. But basically, this is how the informers work. And there was a recent improvement in this in Kubernetes from 1.35. It's enabled by default on the client. That basically optimizes this and says that, okay, I'm basically going to stream you the first resources too, and you don't have to do this list pagination. And after I stream the initial list, there will be a bookmark, and then we'll just continue streaming you the resources. So this was kind of a very good memory-wise, memory pressure-wise, was a nice improvement on Kubernetes API server, but it still has the same issues that sometimes needs to reconnect, there is still the timeout, so that those kind of lags happen still. And Kubernetes controllers are nothing more just a collection of these informers. So we have these resources, informer for our custom resource and all the resources that we manage. So we get notified about the updates of these resources that we care about, and we just, with the callback, process the events for the event processing. In Go, there is a little bit different terminology than in Java operator SDK, but it's very similar. It handles concurrency, so it calls your reconciler, your logic, basically, that you write in a way that it's not concurrent, so it's for one custom resource, only one parallel execution is running, and handles rate limiting and error handling. So basically, this is what controllers are. Just some notes on the reconciler. It's one of the interesting parts. It should be in idempotent. So that means if it might actually execute again and again from different resources. It might execute again on a retries if something failed meanwhile. So it's the idempotency is kind of a must-have there. And it's level-based approach, or level-based. What does it mean? Basically, we don't get these events in the reconciler. So these events and callbacks are coming, and we know there was an update on our config map or pods or deployments, but we actually don't see those updates in the reconciler, in your logic. The reason of this is, it's more, so it's not just one, but basically, ideally, you always work on top of the current state from the caches. So imagine that if you would, your controller would be down, you would miss those events simple. You would always have the latest state always in the cache, but that is always there. So how does it look like in Java? Basically same in Go. Have a simple main function called operator, register me a simple reconciler that registers a controller, and this reconciler implements a simple interface called reconciler for our custom resource for this purpose. And if we are going to do this hello world kind of thing, so we create a config map that copies from the spec part some value into the config map, and at the end we will just update the status of a custom resource with some generation. We call it observe generation. So if I generate the CRD for this with fabricate client, I can kubectl apply this. Also, I will create a sampler custom resource for this resource. And I can, a very nice property that of controllers that we can run them locally here. So if I run this, it will reconcile the resource, reconciling, and if I check this with K9s, we have the custom resource here and should have a config map created here with a value. So notice here these owner references which we are creating, adding to this config map. It's created here. So that points to the primary resource, to the custom resource. And we register the informer for this config map. So if anything changes with the config map, we are getting notified. And that's it. Basically, that's the hello world simple controller. We get this notification every change, even the or sample resource or the config map resource. Just some nuances about the triggering. So when our custom resource changes, we trigger the reconciler. For config map, we are mapping it from owner references. So if we know there is an owner reference from our sample resource or DB here, we are going to take those values from the name and the namespace of the config map and trigger that database or sample resource based on this owner reference. And that's the core of it. Just few words on error handling. It's essential that you have some automatic retry in every controller. It's think of it like Kubernetes API mandates that if you do an update of a resource, it always uses optimistic locking. So there could be always a conflict that will throw you an exception in Java or error in Go. And then in that case, you want to basically wait a bit until the new resource gets through these informers into the cache, and then it retry and likely will succeed. So it's always, by default in Java operating, there is an exponential backoff retry. You can customize it. And yeah. Server-side apply, I won't go into details, but that's helping a lot, also with some of the other cases. And there always needs to be a rate limiting that, I mean, not mandatory, but it's harder to get it right, so we don't have a default because it really depends on the use case. It basically, we already also in Go and Java have a thread pool and the limit of concurrency. So that's already does some kind of rate limiting, right? But if we have multiple these informers that are triggering and receiving the events continuously, it can always, basically it can happen if you don't have rate limiting that the reconciliation is triggered and triggered basically continuously in some extreme cases. So it's not desired, it's level based. So it's, if you postpone it later and we then reconcile it again on actual state, that's just fine, right? It's based on how the logic is designed, it will work with and won't put too much pressure on your system. So yeah, rate limiting is the other thing that this core of these frameworks are always handled. In Go, there is also kind of a burst rate limiter, but yeah, it's, I think, a little bit questionable if that's the right approach. Okay, and so everything is nice and pretty until it's not. And one of the biggest issues, or I think was with the pattern of Kubernetes operators, was the state management, when you have to store some state somewhere. And this happens, for example, when you have a resource that is typically with external resources, we see a lot that you generate some RDS database in AWS. It's very common that you manage non-Kubernetes resources, or just think about a GitHub issue that has a generated ID. You have to store this ID somewhere, and usually we are storing into the status of the custom resource. Yes, that works, but there are some issues with eventual consistency of these informers. So if I want to store something in the status, how does it look like? Let's consider just our sample with a config map and the custom resource, basically the hello world. And what we will do is update the config map as we did in the sample, and also patch the status of the custom resource, so add some value there. So these will trigger the reconciliation again. And after they trigger the reconciliation, we will do a counter and do it again. So let me, better if I show the code directly. So we are going to do this, have a counter that is incremented, and creating the config map in the data with that integer value, and also updating the status with that integer value. So this will trigger the reconciliation again, and here are we going to do some checks, and actually we are going to check if we have the up-to-date resource from the status. And you can see that we have eventually consistency here. So we might get different orders when we are receive these up-to-date resources in the cache. If it's a stale from the patch, so when we have the generated ID, not having it in a status up-to-date, it's a problem because you don't know if you already created the external resource or not. You might want to just create it again. So we always want to have kind of a strong consistency here. So if I run this with the eventual consistent reconciler, basically you can see that it's not some theoretical thing. It will happen like every 5th time that we have stale status in controllers. So this eventual consistency really matters on these cases when we have storing these IDs. So how to solve this problem, which is there in Kubernetes for a very long time? Well, the nice answer, if you use Java Operator SDK, it's super simple. You have just update your version to the newest one and run it again. And you will see that this never happens again. So we will never get stale updates again. And if that's not enough, we have some new internal APIs for updating the resource. So if you use that API with server-side apply here, even more magic will happen. It will just execute once. And why is that? So if you update the resource and you are basically, you know that resource, the up-to-date resource in your caches, and that's a desired state already there, then you don't want to get notified on your own updates. So why would you reconcile your own updates when you are already in desired state? So if you update your controller this way, it basically spares you lots of reconciliation cycles. It also kind of creates much more simpler mental models. So you don't have to think about in these cases of eventual consistency. You know that these resources will be always there from your cache, so you have just much less cases that you have to think through And believe me, that's sometimes really an issue to think in these orderings and stuff like that. So how this works and why now? So why this version of Java Operators we released in March? And Kubernetes guidelines changed. And they said, I think last year was this, that if you are able to get the resource version from your custom resource, this one, and parse it as an integer, then you can use it as an integer. And this simple change of guidelines, actually no code has been changed in Kubernetes. Allow that, so we can get the up-to-date resource on the response, put it in an additional cache, and we receive events, we just compare resource versions with the top on that additional cache, and just evict it after that we receive the resource. It's probably the most complex algorithm in Java Operator SDK, and we iterated about 4 times on it until we get the final results. And also we had to unit test the hell out of it. But it's working very nicely now in production in lots of operators. So yeah, and this is now in progress also in Kubernetes core operators for daemon set and stuff like that, but also in work in progress in Go control runtime, which is for the open source Go operators. So that should arrive, I guess, there soon. And I have one more interesting part, so a news in this world. So Kubernetes operators doesn't really scale. They are in control manager. If you know core Kubernetes operator, just one binary basically running, or one pod. And also, if you are running, sometimes with replicas, there is one leader which actually does the reconciliation, others are passive. And this is a fundamental problem from beginning with Kubernetes operators. They are not scalable, really. And there were some hackish ways, like you could do some labels and label selectors, but again, then it's scaled, but not auto-scaled, and it was a pain to do that. And in the version 1.36 that was released recently, it basically says that on these informers and the list and watches, now we can hash these either the UID or the namespace, and we can tell the Kubernetes API, just give me from this range the hashed values. And basically this allows sharding for the custom resources or any resource, but you will do it for your custom resource. And basically this is now alpha, so and also in Java SDK is coming in the next minor release. It basically solves this problem with some asterisks, but more on that maybe later. Or maybe in the questions, because that was my last slide. Thank you very much.
Okay, Attila, thank you very much for your presentation. We have one question in Slido, but I would like to ask you, audience, do you have any questions? Do you want to ask a question in person? Somebody? Okay, no. So here is a question from the Slido. What do you think about using informers instead of mutating webhooks?
Yes, that's a good question. So it's a little bit different thing. So mutating webhooks and validation webhooks works on a request basis, right, in Kubernetes. And there are things you want to do before it gets to the API server or etcd. And then if you want to do post-processing after etcd, basically then you need controllers and informers. So it's a little bit in different position in this chain. But yeah, there are some, but also in the validation mutation webhooks, you can use informers in those. So you can manage the state, and that's actually done in practice, that you're running as a pod, the mutation webhook, and you cache the resources inside those using informers. So it's not one or other, it's basically it's also combined.
Okay, thank you very much. Do you have any other question? Okay, I think no. So thank you very much again.
Thank you.
Thank you. Thank you very much. Now, okay, now we are starting with our talk. Here we have Thomas Schuetz. No abstraction to rule them all, navigating the many ways to build platform interfaces. The stage is yours.
Okay, so hello everyone. I always like these AI-generated titles of the talks. But before I start with my talk, as this is the last talk for today, just give a warm applause to the MC of today because he did a great job. Thank you, good. So, hello, I'm Thomas. So, I'm a cloud native trainer, architect, and advisors in my own company called TSC Labs. So if you see the logo on the slides, this is me. And I'm a Golden Cube astronaut, I'm a CNCF ambassador, and some years ago I was a tech lead and co-chair of the CNCF Tech App Delivery. And one thing I did there was I wrote a white paper around operators. And this is also kind of a thing which brings me to this talk for today, because since then I'm trying to avoid writing operators and white papers. Nearby, I'm a lecturer for cloud native technologies at Universities of Applied Sciences in Austria. And I see this kind of my mission to make cloud native approachable to people and empower teams and people to build their reliable platforms. Good. So why are we here for? What is this talk about? So in the end, we want to get our services and applications deployed. And this should be in a way that it is as simple as possible, as you see on the right side of the slide here. So I want to have a simple resource definition in Kubernetes where I can define which image I want to deploy, which size it should be. If I need a database, sometimes yes please or oh no. And sometimes I also need a storage bucket to store my files somewhere. But all over the time, when we are starting with Kubernetes and when we are moving on, we drift away from this. So we are always finding ways on how to make things more complicated. And throughout this talk, I also want to give you an idea on how you can make it easier again, how to harmonize it, and all of the tools we find along the way. And in the end, maybe we will get back to our target state. So let's start. When we start, what are abstractions? So mainly, they hide some complexity behind a description. So if you're thinking about Kubernetes on its own, it's not only the definition, right? So it's only the things Kubernetes is doing. As an example, if you are creating a pod, somebody thought about it, said, yes, I need to get the configuration from somewhere, I need to create a namespace, I need to spin up a process and monitor it somewhere. These are all things where somebody thought about it. Often, such things reduce cognitive load. Sometimes, if not done right, it might increase the cognitive load a bit. And it's meant to be to simplify things. And in the end, if we think about it, every resource type in Kubernetes is an abstraction. Good, so how do we start with Kubernetes typically? So I'm a trainer, I'm also teaching Kubernetes stuff, and one of the first things my students are doing most of the time is we are creating a deployment and we are creating a service. Cool, 20, 30 lines of YAML code and everything is fine, right? Or not. So this is where we are after some hours. So in the meanwhile, you need some configuration. So yes, in the beginning, you can add it to a deployment pod, whatever. We need some secrets. By the end, we know that we are not allowed to store secrets in Git, so we need external secrets, so everything gets funnier. We learn that it's not a good idea to use the default service account everywhere, so we need our own service account. And in the end, we also need a deployment, a service, and nowadays an HTTP route. Good, but with this, it's not enough. So after some time, we also find out that our company needs databases, storage buckets, whatever infrastructure resources. So one of the first things we start when doing cloud native stuff, and we are doing cloud stuff, is we are finding ways on how to provision cloud resources using OpenTofu, Terraform, Pulumi, and so on. And yes, you guys from Crossplane, I know you. Good. And we also learned that we need more things inside of our deployments. So we want to deploy our services to multiple regions, multiple zones, whatever. We need security contexts to stay some kind of secure, and so on. So to this many lines of YAML code we have now, we get more YAML. And last but not least, we want to make it configurable dynamically. So we want to add more replicas. We want to make everything as configurable as possible. And this is the point where we get to templating and overlays. Good. What's the deal with templating? So usually, when we start with all of these things, we learn about two things. The first one is customize, which is often pretty cool when it comes to configuring simple aspects of configurations. So add replicas, add images, and so on. But in the end, I saw customized files which are much more than an overlay. So you get very complicated JSON patches in there. You have the space overlay construct, sometimes combined with GitOps, which leads to some catastrophic situations, and so on. So such customized overlays and so on are hard to distribute, hard to update, and hard to maintain sometimes. On the other side, the other part of the story does not look much better. So we have Helm charts, which provide a pseudo API for your templates. The pseudo API is meant to be a YAML file. So you can define a schema, you can define which aspects of the configuration you want to have configurable, and therefore your developers can use it. But often, we tend to create such generic charts which will get embedded as dependencies, and this also makes it challenging to distribute for us. So if we want to distribute one Helm chart as a dependency to 200 of services and have a breaking change in there, many developers might get a problem, right? And by the way, what's about our infrastructure code? This is still nothing in there. Good. So we have some templating and we have our infrastructure stuff. So as I told you before, we have this deployment, service account, and so on. And in the meanwhile, we also have our databases, object storage, service accounts, whatever. And nothing bad about it, or sometimes it gets really bad, because in fact, what you're building here is a hard dependency to an infrastructure team or to the guys who are maintaining the whole infrastructure code. So what I've seen in the wild out there was that application teams have to ask or inform the platform team upfront to deploy Terraform code before they could deploy their application. And I think this is not what we want a cloud-native application to be. So, just to remember, the thing on the left side was the target state we wanted to have. In the meanwhile, we have this Helm chart, Helm template, customized stuff, and so on, with, I said, more than 500 lines of code. I didn't measure it, but it might get much more. We have a values file with some 100 lines of code, and we have infrastructure code, tons of them, and this is maintained by others. There must be a way to do this in a bit of a more comfortable way. And yes, Crossplane guys, I have you. This is where some other infrastructure operators come into the equation. So in the meanwhile, every major cloud provider has their own operator. So we have ACK from Amazon, we have KCC from Google, and we have ASO from Azure. Furthermore, I know that there are Terraform operators out there. Not sure if they make our lives better or harder. And finally, we also have Crossplane. What does this bring for us? So on the one side, we get our Kubernetes primitives in the meanwhile, and on the other side, we have the infrastructure. And the cool thing about it is we can deploy these two things together. So the dependency to our infrastructure team, or the people aware of the Terraform code, gets a bit smaller, let's say it this way. But what we still have is our chart or our overlay. Good, so what gets better now? So yes, at the beginning, our app and infrastructure code gets closer together and we can deploy it together. So, cool thing. Furthermore, our infrastructure is continuously reconciled. Also something new what we didn't have until now. So before you had to deploy your Terraform code, you had one of these clunky GitOps pipelines maybe. So you had a pipeline to deploy infrastructure before you can do something by GitOps, also a very cool thing. And we have Kubernetes objects for our infrastructure now, which makes it sometimes better in terms of visibility. And also if we have Argo CD or whatever, we might see much more than before. And now you think everything is fine. We have our infrastructure in Kubernetes. And yes, we have 20 minutes left. And what are you talking about, right? What about the other 500 lines of codes in shell script? Which you need to configure your application. So maybe when you are deploying your application, this application might need some configuration, right? So sometimes you need to create admin users. Not sure, sometimes you need to do something on the API or whatever. And also there you have choices and you have options to achieve this. So maybe you want to take this shell script, put it into a cron job, put it into a job, run it as a pre-install hook or whatever, and everything's fine. Maybe not. And what if you also add such configuration in Kubernetes native resources? So some of you might have seen the talk before about Kubernetes operators and how they are working. So in some cases, it might make sense to create an operator, but only if you know what you're doing. But why should I start doing this? So one of the things I always talked about when people ask me when they should start with an operator project is start such a project when your application has a very complex lifecycle. So, or you need to ship it to your customer's premises where you don't have control over it, and if you know how to write operators and how to maintain them. But always be aware, when you are creating such an operator, you are starting a development project. You get maintainership, and people will come with feature requests to you. So I started such an operator project to deploy applications some years ago by myself because I thought it was cool. The backlog was full after some weeks, and I wasn't aware, and so I wasn't sure how to implement all of these features into this operator to get this running at some time. But it's still a cool thing if you need to run your application in autopilot. So, as I said, if you need to configure custom APIs, if you need to run it on custom APIs, everything is fine. Good. What should you consider when you're doing this? So we have lots of frameworks out there, and all of them are nice. So we have a shell operator framework, the most important one. I never tried it. The other one was KubeBuilder and Operator SDK. I think most of the operators come from there. In the Operator SDK, you have the choice between Go and Java. I'm not sure if there is another language in the meanwhile. You have COP for Python, and so on. When you are starting such an operator, it's always a good idea to not start with the code itself, but to start with the specification, because otherwise you will get back to the Helm chart you had before. So it makes sense to work the same way you would do in a typical software engineering project. So to write an API specification, to find out which fields you need to be configurable, to talk to your customers, find out what you need, and then it's very easy in the current operator frameworks and so on to make this work. So it's good to follow an API-first approach. Another thing is maybe you will deploy these operators to some clusters. Hopefully. And you might need permissions to run this operator on this cluster. And I know from very early times, I've seen it very often when an operator had cluster admin rights. I think this is not a good idea. So you should try to find out which permissions does my operator really need. What can I do to build trust into my operator? So if somebody installs this operator, that he or she can find out what will be done here and create the RBAC rules accordingly. So what you see very often in operators is that you have a separate RBAC files or something in the charts or whatever, where you can see what this operator is doing. Good. And last but not least, so writing your first operator might not be your biggest problem. This problem comes much later, and this is where it comes to versioning, upgrading, and whatever. So I think many of us know what happens if you are removing CRDs or removing CRD versions or whatever. And therefore, you have to find out, how can I deal with the conversion between one version and the next one? How do I deprecate my APIs? And so on. So lots of things that can go wrong here. Perfect. Nice cloud native world. Good, but after some time, we have also our own capabilities in there. So in the meanwhile, we have this cool Kubernetes primitives. We have our infrastructure operators. Yes, and sorry, crossplane guys, I forgot crossplane here. So we have our infrastructure operators, sometimes also databases and so on are provided via operators. And in the meanwhile, you also have your own operators. So your chart gets larger and larger, and it's more likely that you will have breaking changes in your chart as at the beginning. Good. What can go wrong now? So you have to distribute the Helm chart, right? So you have your OCI registry, push it there, have renovate, update it. Unfortunately, everything breaks now. Good. Second thing is you have a massive complexity in the chart. So yes, the first Helm charts, the first customized configurations and so on, always look very sweet. And it's very cool to template something. And at this point, everything what you configured at the beginning might be one thing that can break now. So what I started to do when dealing with larger Helm, with such larger Helm projects is really to write unit tests for Helm charts. So there are frameworks for that, and sometimes this helps you or this saves you from breaking something. Troubleshooting might get more interesting, and sometimes you also get to some client-side issues. So maybe people are changing values files, maybe they are not checking for the schemas and so on. So you will need additional steps in your pipelines which will validate these values and so on. So everything gets more funny. Good. Just to get back one step. So this is still our goal, right? So we want to have a very simple configuration. And at the moment, it would still be possible, but we have lots of code. Now we have two options. So I'm pretty sure some of you know about the concept of operator of operators. Yes? Good. Whom of you created such a thing? Okay. Yes, me. And the second thing we have, and now is we can use such things as composite resources. So we can find some tools out there which help us bundle such things and get us out of this hell. Let's say it this way. And for this, I know that there are much more options out there. I want to touch 3 of them. The first one is crossplane. Yes, crossplane guys, I have you here. The second one is Villela and the open application model. And the third one is the new star rising, which is the Kubernetes resource operator. And just let's take a bit of a look into all of the three ones. At first, for the crossplane guys. Initially, for crossplane, so when I learned about crossplane, and this was some years ago, and I was always very enthusiastic about it because it brought the option to get Kubernetes resources, to get infrastructure resources into Kubernetes. Initially, for me, it was a tool to get these resources inside of Kubernetes, and I was not aware of the compositions part and so on, so not sure since when this is there, but it seems like this got better. The cool thing about crossplane is it provides such compositions, so you can create your own resource types. So such composite resource definitions, XRDs, which can be implemented via compositions, so the logic behind them. And this logic is very powerful. So you can do almost everything. I think in the meanwhile, you can also use whatever language you want to write such functions in such compositions. And maybe for one or the other tasks, crossplane can save you from writing an operator. So it's a very cool thing. Traditionally, for playing Kubernetes resources, it needed a provider to add them to the compositions. In the meanwhile, also this changed. And I heard yesterday one of the drawbacks of using this is sometimes it is not so native anymore as using the provider stuff. Did I get this right? Perfect. And But I felt this would be a good way to create such composite resources in the end. So for me, cross-plane compositions look very great when the logic of such resources is very sophisticated, but also the learning curve of creating such compositions is a bit steep. So this was what I found out in the last few weeks. Good, then we have the second one. This is Kubevela and the Open Application Model, and this was an approach to standardized application definitions. So you had such web services as defaults and so on, where you could add some images, whatever. And using Kubevela, you have a major implementation for this. So I think also Crossplane used the Open Application Model at the beginning. I'm not sure if this is still the case. The concept behind Kubevela is based on, or the Open Application Model is based on components and so-called traits. So on the one line, you have the components such as web services or whatever you want to define on your own. And on the other side, you have the operational aspect of all of this, such as autoscaling, such as sidecars, or whatever. So it's possible to define your own components, but I used such thing in production. And what I found out is sometimes it might get you back to the problems you had before. So you could not, yes, you could define your own components and so on, but you are still in this application boundary. And sometimes it gets hard to maintain all of this. Good, and then we have the third thing, which is the Kubernetes resource orchestrator. And for me, this was one of the main parts why I wanted to create this talk. So I wanted to find out where's Crossplane, where's the Kubernetes resource orchestrator, and so on. And this is a sub-project of the Kubernetes cluster provider. Cloud provider, sorry. And initially, this was initiated by AWS, Google, and Azure. And I think the goal was that they said, we have our operators, let's simply combine our stuff with deployments and so on, and build something where we can build such abstractions. What you will find out if you try it out, that this project is still in a very early stage. So it's very cool to write things in there because you get to a composite resource definition very fast. But if it gets more complicated, then you might face some issues and you might not get out of it. And if you face such issues, it might be a good idea to get back to Crossplane and so on. Good, and I just wanted to give you a short idea on how such composite resources or resource graph definitions in Crow can look like. For this, for my trainings, I have an application which is called the Learning Tracker. This is a simple Kanban tool, whatever. And in this case, it will consist of a service deployment and a persistent volume claim. Furthermore, I need a MySQL database, which I also added into one composite resource. So, sounds like, it feels a bit like playing piano, and I never played piano. Good, so in this demo, I created 3 files. The first one is a resource graph definition, so a definition of such a composite resource for my MySQL. So I said I want to have a common resource in my cluster for a MySQL. The second one I created was a resource graph definition for the so-called Learning Tracker, which puts everything together. And I know there might be pretty examples for that, but this was the best one I found at this moment. And the third thing was the thing I wanted to deploy finally. So this is my deployment specification. And you might see that this is kind of a definition I mentioned before. Yes, in this case, I have no container image in there. This is because it's not so generic. But in the end, I can deploy this application with this few lines of code, which sounds like a pretty good idea for me. Good. Then let's take a closer look at such a resource graph definition. And I felt like this is kind of similar to what we see in Crossplane. For Crossplane, some things are more mature, and some just want to avoid the term sophisticated. But it makes sense that it is more sophisticated. Good, so we have this schema here. So we can define, we want a MySQL database, we want to have a database user, and we want to have a database password. And no, I would not do this in production to add a database there, so I would add a secret typically. Good, and in the end, we want to get out a database endpoint so that we can configure this somewhere, and we want to find out if everything is ready. So the whole configuration language of this is not very hard. Then we can add some resources to it. So we have this deployment, the apps v1 deployment, whatever, and I think what you see here might feel very familiar to you, right? So this is a typical Kubernetes resource definition with some templating stuff. There are some cell expressions you can also use for Crow. I tried it out. Sometimes it works better, sometimes it works not so good. But in the end, you can do many things in there. And you can always add some things from the schema and whatever. Furthermore, I added a service, also with some templating magic in there, and I also added this PVC to get this running. Good, this was the resource graph definition for the MySQL, and let's simply apply this. And before I do this, let's take a look at the CRDs of our cluster, and at the moment, there is no MySQL in there. If I apply this, let's take this. I have this resource graph definition. I can take a closer look on it. So as here, I have this MySQL database. This is active and so on. So as soon as it's active, you are safe. Maybe. And the cool thing what you get here is I get a CRD. So yes, this CRD has the API group Crow run, but everything's fine for me at the moment. And I could use it to spin up a MySQL now, really in a really simple and convenient way. And also could reuse it for other purposes. Good, but now I said I want to deploy my application more often, so maybe this is a SaaS application which has to be deployed much more often or whatever. And therefore, I defined a second, a bit more sophisticated resource graph definition. And this also has its API, this has a repository. In this case, I also used some kind of defaults. I have a version, database type, and so on. Then I have this deployment with all of the things I need in there, with some links to the schema spec, but also with some status stuff of the database. So I added the database RGD I created before as a second resource, and therefore I can use things from the status in there. And now let's also apply this. Okay, so in the meanwhile, I have 2 resource graph definitions and 2 CRDs. I think you can trust me. And just before I apply my configuration, you see there is nothing in my default namespace, and no, I would not deploy something to the default namespace typically. And let's apply the deployment now. Deployment. And obviously, we will see that we get a MariaDB pod, we will get a learning tracker application, we will get the services, and so on. If I would port forward to it, everything would work. And I also get this PVC bound to bound to my pod here. So everything is fine. I can manage everything with this one resource. And at the moment, until I don't have more conditionals in there and so on, I would be happy. Good. Let's get up from the piano. And where's this one? Good. So we have some kind of a target architecture now. So at first we have our we have our composite resource. We have some Kubernetes primitives. We have our infrastructure operators. Yes, this could be a cross-plane operator now. This could be an ACK stuff or whatever. And I could have my operators. Everything managed by a platform team. If they would update it, all of the things would get updated. Yes, you would have to deal. You would have also to deal with breaking changes, but you have possibilities to do something against it, and you are more in a platform-like environment now. Good. So I'm almost at the end of my point of my talk. So what did you learn today, if you didn't already know it? At least some of you laughed. A Kubernetes application deployment doesn't consist of a service and a deployment in the real world. So we have much more resources. We need much more things to get our services up and running. Over time, infrastructure will get an issue. So it's a good idea to not have it in Terraform, but use other either cloud provider provided operators or cross-plane to deal with it. If this is not enough, you can create your own resource types, either with Terraform or with cross-plane compositions, functions, and so on. And if you simply want to combine resources, you don't have to write an operator. And you can use Crow, crossplane, and so on to make it work. And there are ways to create such resources. And with this, I hope you had as much fun as me. I hope you had a nice conference. And thanks for attending this talk. And yes, I'm not sure if I have time for questions. Thank you.
Thank you very much. Thank you very much for your presentation. And now for the audience, I'm asking you, do you have any questions? Are there any questions? Okay, no. I don't see any questions in Slido, so I think that it was really good. Thank you very much. Bye. Now, please don't go home, go to another room, and there will be a raffle. We have some nice prizes like the 3D printers and other stuff.